And we should be live. So we're not doing call-ins, at least not for the first hour and a half. We will do call-ins after the normal Ask a Physicist hour and a half has finished. And then I'll bring up what they're called on TikTok as superfans or members on YouTube. Then we'll bring those people up and answer some questions and, you know, hopefully entice people to become members because, you know, supporting me helps the channel. All right, well, here we are. We should just let people trickle in and start asking questions, and we should be good to go. Unfortunately, I'm wearing a shirt that seems to have shrunk in the wash. It feels a little on the tight side, on the small side. Oh, I gotta connect up the TikTok to the chat window. Howdy, howdy, everybody. 1 minute late, fallen off. True. I have indeed fallen off. Yep, definitely true. How is everyone today? Well, I don't know how everyone's doing, but I'm doing okay. Can I join up? I got a question. No, I will be taking guests from the membership community, from the superfan community, in about an hour and a half. So if you want to stick around and become a superfan and then come up then, by all means. Hope your nose is healing well. It does seem to be healing up. It seems like I'll be left with a scar, which is annoying. But it is what it is. That is the world that we live in. Would you be open to having a formal debate on is the Torah from Sinai or a later invention? Well, it doesn't seem like I'm the kind of person that you would want to debate on that, because it seems like you would just want to debate like a historian or like an archaeologist or perhaps a critical scholar or something like that. I'm just going to repeat over and over again what it seems like the academic community says. The academic community seems to make the claim that the earliest text that we have from representing the Hebrew Bible is maybe from like 900 or 1000 BC. But most of it comes from perhaps the exilic period, maybe around 500 BC and so on. And I'm just basing that off of what I've heard historians, archaeologists, and critical scholars say. Anyway, let's answer some questions. In the Big Bang Theory TV show, when they talk science-y, is it accurate? It generally is pretty accurate, yeah, with some exceptions. Oh, actually, I guess that we should do the monofocal cleaning because my glasses are a bit dirty. The OGs will know the reference, by the way. Let's clean the glasses. There we go. Do you think FTL will ever be possible? I suspect not. This is probably one of those things that we have this intuition that it should be possible because, you know, what do you mean? You can't just, there's just a speed that you can't go past. But like, it could just be that in our universe, this is not the kind of thing that can happen. Even though science fiction makes it seem like it's easy. Is nature actually fractal, or do fractals only hold over limited ranges? I mean, nature is, it's not technically a fractal, meaning that it doesn't have actual it doesn't have actual self-similarity, but it's approximately fractal in like some sense of the word. You have a bachelor's, master's, PhD? Yes, I have all of them. Can you explain how an object's gravity slows it down? Well, an object's gravity, if you mean how it slows its time down, well, that's just because gravity is the curvature of space-time. And so you have to understand that when we say space-time is curved, that includes the time part. If we could survive the event horizon, what do you think we'd experience in a black hole? Well, so at least classically, there is no reason to think that the event horizon is a special place. So for a particularly large black hole, you could, or at least we would expect that you would absolutely survive the event horizon. You wouldn't even notice that you passed the event horizon if your eyes were shut. So eventually you would get closer and closer into the center of the black hole, and at some point you'd be torn apart. because regular matter can't survive sufficiently deep into a black hole. Why are there snow on top of mountains if they're above the clouds? Because the air cools down as you get to higher altitudes. The air is warm not because the sun is heating it up, but because the ground is heating it up. The sun basically passes through the air. It basically doesn't heat up the air at all. It heats up the ground, and then the ground heats up the air. Could the universe collapsing create another Big Bang? Maybe. This is something that we don't know yet. To our knowledge, have we learned everything about gravity? No, there's stuff about gravity that we haven't learned. Like, we don't know how gravity behaves at a quantum level. Where does magnetism come from in quantum physics? It comes from the electromagnetic field. In particular, it comes from static configurations of charges. What is the probability that there are other life forms in our galaxy? That's pretty hard to compute because we don't know exactly what the conditions required are to form any kind of life. Have we used neutrinos on other planets? Well, people haven't been on other planets, unless you count the moon, but that's a moon, not a planet. What's your thought on that whole we live in a black hole thingy? I don't think it's true. And I think that we probably have good reason to think it's not true. Namely, if we were to live in a black hole, that would suppose that there is basically nothing outside of the observable universe, which would be very, very strange. If energy can't be created or destroyed, that's not a real question. What's the biggest actual number you can think of? 3. Maybe 5. I don't know. Theoretically, can gravitons escape a black hole? No waves can propagate outside of a black hole. Gravitons are waves, so no. If you did something to produce gravitons while within a black hole, those gravitons would not escape. We've never been on the moon? Sure we have. There's plenty of evidence that suggests as much. Dark matter cluster or supermassive black hole, center of galaxies? I would say supermassive black hole. What were your thoughts on Project Hail Mary if you've read it or watched the movie? I thought the movie was excellent. I haven't read the book. Wouldn't black holes not exist in our universe because they would just merge with the other? Merge with the other what? I mean, like, black holes do exist and they do merge with each other. Are black holes faster than the speed of light? No. No, they're objects just like everything else. They can't move faster than the speed of light. Is there any evidence that can lead us to believe that wormholes exist? Not macroscopically and not for a long time. If spacetime is emergent, what observable ephesus locality is irreducible immanent? That seems like word salad. How are there still people who don't believe in the Artemis 2 launch? Look, man, think of the average person and then think of the median person, the average that's another way of saying average, and then recognize that half the people are dumber than that. Can you explain how the Boss Great Wall formed in that shape? No, I can't. I don't know how the Great Wall formed. I imagine you're talking about the Hercules Great Wall, I think is what it's called. Like a big arrangement of matter that seemingly has structure. Why is our moon so much bigger than other moons? Because our moon is not a captured asteroid, and it's not a captured planetary body. It seems like the way that our moon formed is that something big, like another planet-sized thing, smacked into the Earth and knocked off a giant chunk. What would happen if gravity was not uniform? Well, gravity isn't uniform. Are there objects with gravitational force so weak light escapes? Yeah, like the Earth. Can you explain what infinite density means in terms of black holes? Yeah, it's a presupposition that there is like a thing that has 0 size but contains all of the mass of the black hole at the center of the black hole. This is called the singularity. That's not something that most physicists, or at least a large chunk of physicists, think actually exists. Oh, sorry. How much do you attribute your degree to your genetics versus your work ethic? I don't know. Are you published? Yeah, like more than a dozen times. You can go check out my publications on my website. Go to blitz.phd. All my publications are there and my CV's there. Why are moon rocks different if it came from the Earth? Well, because it didn't come from the Earth. At least not all of it. Some of it came from this other thing that smashed into the Earth. You ever met Neil deGrasse Tyson? I haven't, no. Are there equal parts matter and antimatter? As far as we can tell, no. It seems like our universe is almost entirely matter. Can you explain many worlds? Yeah, the way to think about this is like, how do I want to describe this? So you can think of each world as like, you don't know linear algebra, it's really hard to explain. It's a good analogy. Okay, a good analogy would be like the Powerball. You can think of each world as like a different ball that's plucked out. And so while the cause of each ball being, you know, when you pluck out a number, each number being what it is, might come from the same cause, you get some branching effect, namely like one ball bumps into another, and so on. And so this ball ends up being this, and that ball ends up being that. And the numbers that on each of the Powerball or on each of the lottery number balls, they don't talk to each other. They're separate things, but they all exist. What I'm trying to say for those who do understand linear algebra is that you can think of the universal wave function as being described as a vector in a vector space, and each world is one of the basis vectors that contribute to the vector in the vector space. Did we land on the moon in the 60s? Yes, and in the 70s. Why is gravity the hardest fundamental force to understand? Do we not know a lot about it? I mean, we do know a lot about it. The thing is that it's fundamentally different from the other forces. It's not a gauge theory, at least seemingly. It is well, not a gauge theory. It's a theory of it's a theory of curvature on a tangent bundle rather than on an associated gauge bundle. So it's a different kind of thing. And so our standard techniques just don't work. That we would like to, the standard techniques that we use to like turn classical theories into quantum theories just doesn't work for the gravitational theory that we have. What is the fabric of space-time? Sun sits on fabric equals gravity, but what is the fabric? Okay, so this is where the analogy goes wrong. The sun isn't sitting on the fabric. The sun is in space-time. Space-time is a thing, or at least it's, you know, it can be treated as a thing. And it's not like the sun is like weighing down something. It's just the presence of the sun causes space-time to respond in a certain way. Space-time is, as far as we can tell, it's just part of the universe. Is being a physicist what you hoped it would be, or is it more stuck in a room reviewing data for days on end? So I don't do a whole lot of stuff with data because I'm much more on the theory and model building side of things than on the data analysis side. It is basically what I expected it would be, but it's a lot harder, which is not a problem. Is that a Feynman diagram behind me? It is, yeah. Antimatter versus dark matter difference, they're different kinds of things. Antimatter is basically regular matter, but kind of opposite. It's opposite in all respects except the amount of mass that it has. So if you have an antimatter version of an electron, it's called a positron, and it has positive charge rather than negative charge. Dark matter is a completely different kind of thing. As far as we know, it doesn't have charge of any kind. It's not like just the opposite of some kind of particle. It's a completely different kind of particle, or if it is a particle at all. Why aren't we going back to the moon? We are. We just sent 4 astronauts around the moon like a week ago. Do you tend to imagine model physics in your head, then test the math? Yeah, basically. That's what I, well, it depends on what I'm doing, but yes, that's the tendency I have. What's the most convincing argument that we're missing something big in physics? Well, it's not that we're missing something, it's that we don't yet have it. And the argument is merely that we have two very, very accurate models of the world. We have general relativity, which is extraordinarily accurate. Oh, for some reason, YouTube messages aren't being picked up. We have general relativity, which is extraordinarily accurate at the large scales, and we have quantum field theory, which is very, very accurate at the small scales. And for some reason, they can't talk to each other. We don't know how to make that happen. And so that fact, somehow we have two things that are correct, but they can't interact with each other, suggests that there's something deeper going on. And we don't know what that is. We're not missing anything, we just don't have it. Well, look, so what I mean is that there's not like something obvious that we're missing that we should already have. It's that there's more progress to be made in some regard. That's what I mean. Sorry, I missed some super chats because my app was being wrong, so let me read them. So from Icy Spin with the $5, Flurf today said the universe can't expand into nothingness, so globe model is cooked, bro. I know why they're wrong, but would love to hear your POV. Well, because expansion doesn't really have much to do with any edges. The universe, as far as we can tell, doesn't have edges. The universe, as far as we can tell, isn't stuff and then nothingness. So that's just a misunderstanding of what the globe model says. And from Strikarzi with the €250, what do you think of the one electron universe hypothesis? It was a good idea back when we didn't know what quantum fields were, but now we know what quantum fields are. So there's a better explanation as to why it is that there are so many, why all of the electrons are the same. Sorry, I have to go pull up the super chats from the other live stream as well, because it's also being dumb. Let me actually, one sec, let me pull something up. Come on. I know there's a way to make it. Oh, there we go. Okay, good. I can use this so that just in case. Oh, no, I can't. Okay, I don't want that then. Okay, well, the messages should be coming through. From Solar Lion with the 7 Canuck bucks, what are the odds of a major breakthrough that reveals entirely new laws of physics beyond our current understanding? I don't think that this is not a thing that we can put odds on, right? Like you're not going to be able to put odds on like anything that has to do with predicting the future about how many times, you know, somehow like or some major world event will happen. You know, it's just not going to happen. At what point in physics does temperature no longer become a variable factor? When you stop having something that is in equilibrium, temperature is not really a relevant factor. When you stop having something that can be described as large collective behavior rather than a bunch of individual small behaviors, temperature is not really a factor anymore. The news reports frequently on quantum teleportation. Is there any possibility of this phenomenon being scaled to teleport larger items, people? I guess, but you have to realize that what quantum teleportation is that you have some arrangement of matter in some configuration, and then you delete that arrangement or that configuration of matter. You delete that quantum state, and then you kind of transfer it somewhere else. So, it's more like destruction and then exact copying somewhere else. It's not something disappears here and reappears there. It's not like that kind of thing. If you didn't get into physics, what would you be doing and why? Well, I'd be doing math, but I'm kind of doing math now anyway. So let's instead say that I would be doing, it's doing it again. For some reason, it's not picking up the super chats. I'm going to refresh something really quick, but from Matt Swenson with the $5, if black holes form from matter or energy squeezed into a small area, why didn't the pre-inflation universe collapse into a black hole? Well, some of it may have. These would be primordial black holes, but more importantly, what you need in order for a black hole to form is not from it it's not just enough matter or energy squeezed into an area. It's enough matter or energy squeezed into an area and then less matter and energy outside of that area. You need some sort of over density. Now I'm going to restart my my social stream ninja thing because it seems like it's not picking up on the live stream. It's being buggy. So hopefully this fixes it. And if I missed somebody's super chat, please, mods, if you could let me know, that would be really, really good. That would be ideal. And mods, if you can let me know if the YouTube questions still aren't showing up in the horizontal stream, that'd be good too. Did the Van Allen belt really allow the Artemis 2 to go through unannounced? The Van Allen belt is not really dangerous. What you don't want to do is you don't want to like hang out in the Van Allen belt for hours or days on end. But like passing through the Van Allen belt is like the equivalent of like a chest X-ray or maybe a CT scan. The radiation's not that dangerous if you pass through in like an hour, and the temperature's irrelevant because the actual thermal content, like thermal energy content, is basically zero. How much more time would we have if we didn't have to reboot, restart? Well, I'm not rebooting the live stream. I just had to reboot like a social stream ninja thing. It was just being annoying. From a guy named Dan with the $10. If the United States had built a superconducting super collider decades ago, would solve current questions and things such as dark matter? No, not necessarily. Because as far as I know, even though the energy would have been quite high, the luminosity would have been fairly low compared to what we have now. And so we still, like, unless it's the case that dark matter is just around the corner, in which case we'll detect it soonish, the level of precision that we're able to make measurements of is just not so much. That wasn't good English. The point is that there's two things that are involved in colliders, right? There's luminosity, which is basically how many collisions per second you get, and then there's energy, which tells you about what kinds of things you can make. So if the thing that you're trying to make is rare, then you need high luminosity because you need to produce a lot of collisions to make even one particle, right? If the thing that you're looking for is heavy, then you need high energy. Now, it could be the case that dark matter is both heavy and rare, so you need high luminosity and high energy. The superconducting super collider wouldn't have that. It has high energy, but not high luminosity. The LHC has very high luminosity, and it has, I think, slightly less energy than what the SSC would have been capable of, but or a same order of magnitude anyway. But the point is that it wouldn't necessarily solve the dark matter problem. And from John Deere with the $2, best argument you've heard for God's existence, that it's intuitive. Honestly, that's the best one. Like, there is like, I can understand the intuition for believing in something like that. I think that all of the other justifications are generally post hoc. Yeah, essentially look at the trees, unironically. Okay, so here's a super chat that I missed from Solar Lion, which I can't pull up for some reason, but it's there. I don't know why it's not coming up, but anyway. Have current laws of physics ever been seriously challenged by experiments that produced unexplained or contradictory results? Sort of. So there's the lithium problem. Current Big Bang nucleosynthesis models, this is so in the early universe, the Big Bang, very, very early universe, just after the Big Bang, certain elements were produced. So we have hydrogen being produced, we have deuterium being produced, we have helium being produced. The amounts of hydrogen, helium, and deuterium that we see in the universe is basically in agreement with the predictions by the Big Bang. However, the Big Bang also predicts a certain amount of lithium is produced, but the amount of observed lithium in the universe is off by like a factor of 2 compared with the Big Bang predictions. So that's weird. We don't really have a good explanation as to that. Now, it could be that the Big Bang is wrong, or it could alternatively be that the way that we understand nucleosynthesis is wrong. I kind of lean towards that because nucleosynthesis is a really, really complicated problem. The other things, anything else that's been challenged by experiments that's currently unexplained? Nothing that I can think of that's super major, but I'll think a little bit more on it. All right, let me make sure that things are still going through. Okay, I think that, wait, so why, okay, I'm sorry. For some reason, the YouTube super chat or the YouTube messages just aren't coming through at all. And I don't understand why. Okay, maybe that'll do it if I just keep these open, and maybe they'll come through. Yeah, it was the same as last time. I thought that I fixed it last time, but I think that we have, okay, so we'll try this. This might work better. And I'll just glance over at the other windows just to be sure, to make sure that I'm not missing anything on the regular. Sorry, guys. I know that that's disappointing, but hopefully they're coming through now. Okay. You watch Thunderfoot? I watch Home regularly. No, I don't. I used to, but I don't. Are WIMPs on the list for dark matter? Yes, they are. Can you talk about quarks? So quarks are a fundamental constituent of matter. There's Hank Green wrote a song about this and made a song about it. It was great. But quarks are a fundamental particle. They're the things that make up protons and neutrons, and they can bind together in a very, very strong way that makes them impossible to separate from each other. Can you do a video on how a CAT scan works similar to the MRI video? What happens during my PET scan? So a CAT scan and a PET scan are different. I made a video about PET scans. CAT scans, I think that that's actually on my to-do list. Let me double check. Because I have a very, very long to-do list. And sometimes, yeah, I have CT scans on my to-do list. So, yeah, but that is absolutely on my to-do list, and hopefully we'll get it done soon. What do you feel about the concept of space expanding at inconsistent rate or the space jerk? I mean, like, it seems like our universe's expansion is changing, at least according to recent data. Aren't CT scans just 3D X-rays? They are just 3D X-rays, but that's okay. From Sky Like Mind with the 5 pounds, does the behavior of muons in magnetic fields indicate an undiscovered force of nature? Seemingly, the answer is leaning no. There was a question about an anomaly, the muon magnetic field, the muon magnetic moment anomaly. This was measured by the G-2 experiment. And there was some disagreement between the theoretically predicted values and the experimentally observed values, but the theoretically predicted values got better, and now they're more in line with the data that we have. So it seems like the answer is no, but it's kind of still up in the air. What's your diagnostic procedure power ranking now? Curious to see if it lines up with mine. Power ranking. I've had lots of tubes and lots of cameras in me. I've had a PET scan. I've had in the last 2.5 months, I've had a PET scan, 2 CTs, maybe 3 CTs. Well, there's a CT attached to the PET scan, but 2 separate CTs, a PET scan, lots of tubes in me, an X-ray, some biopsies. So I don't know. My power ranking's pretty high at this point, I feel like. From Strakarzi with the 250, do you think someone who is not inherently smart but is willing to learn can pursue a career in engineering or physics? I mean, yeah. Like, it's hard to say what inherently smart means. People talk about like IQ a lot, but the point is that IQ increases with education. So if you can make it through the education system, then your IQ will probably match whoever it ends up being, or whatever it ends up needing to be, whatever that means. What is element 115 moscovium really useful for? It's not useful for anything. I get my PET scan results today, hoping for clean. Yeah, I hope that you're clean too. CTs are a scary amount of radiation. They're a lot of radiation, but they're one of the best diagnostic tools that we have. You're actually looking very young for a physicist. I'm 32. So I appreciate you thinking I look young though. I don't know, does 32 count as young these days? Is it possible for a universe to be timeless? Yeah, that seems possible. From Germs Rosalino becoming a member for 3 months. sending the message, I bought Sean Carroll's books, excited to read them. Well, good luck, have fun. Oh, my stomach just growled. Do you live in the States? I do live in the States, yeah. Your young 30s is the best time of your life. I feel like that's what people say after their 30s, right? But I feel like the 20s were arguably less painful, less, you know, I feel like my joints and things pop now. Young is always 5 years younger than your current age. Yeah, that's exactly it, right? Are you religious? No. Could we use antimatter as propulsion for space travel? In principle, yeah, but making that much antimatter is really, really hard. I thought you lived in Australia. No. How did you end up on Dean's live yesterday? Well, Dean and I go back a long, long time. And a fan sent me a message saying, hey, Dean is live talking to a moon landing denier. You should go hop up. Dean was on my live on Friday, or on Monday rather. And so, you know, it seemed appropriate that I'd go hop into Dean's live. Turning 40 next month, and my 30s were way better than my 20s. Well, they might be better in some regards, in that you tend to have more financial freedom. You tend to have more... You tend to have your life more together, but like also your knees pop more. From Demtro with the $2, compared to me at 52, you're young at 32, son. Yeah, fair enough. Fair enough. I have a question about relativity and time dilation. Well, you should send the question then. Not that you have a question. Let me drink some water. Gotta stay hydrated. Are you a Planet 9 enthusiast? I can't wait for them to find it. I mean, I guess not. I didn't know that there were Planet 9 enthusiasts, so the fact that I think that I'm not, or the fact that I didn't know about it makes me think that I'm not. We did get a $10 cash app from Grimlock, which is very much appreciated, for a hydration reminder. Pop this up. Did you get any MRI and wait until you get... No, I didn't get any MRIs. I don't know why, but I didn't. Is space-time stretching like a rubber band or expanding like raisin bread? They're kind of the same. They're kind of the same. Why is there so much more matter than antimatter? We don't know. We have no idea. It's one of the hardest questions. You're actually looking very young for a physicist, bro. Are you like 27? Did you not hear? I'm 32. I answered the question already. How do you send a super chat? You have to go through YouTube, unfortunately. There's not really a way to send a super chat as far as I know on TikTok. Do you believe in evolution despite being a physicist? Yeah. Is Pluto a planet? No. No, it's not a planet. If Bob Lazar is telling the truth, how do you think the craft worked? Bob Lazar isn't telling the truth. So, like, this is... Like, I don't think the craft worked. I don't think that it really could work. What are your current research topics? Well, you could go look at what my research is on, and my past research has been on for the last few years. It's on my website. Go to blitz.phd. You can check out my website there. But currently I'm still focusing on conformal geometry. I have a few projects involved there. And then I have a project that I'm trying to make work that involves a recollapsing universe model and entropy, kind of a entropy resetting, trying to make sense of something like that. How does Hawking radiation work? Hawking radiation is pretty complicated to explain. I have at least one video on it, but the best explanation that the explanation that I like, which is fairly close to what's actually happening, is that you have quantum tunneling from inside the black hole to outside the black hole. You have particles inside the black hole, they can tunnel outside, no problem. From Jacob Tablagan with the $5, what do you think is the best way to study for the AP Physics 1 test? Any suggestions on what resources to use? I know that you sent a super chat for me to answer this, but I didn't take the AP Physics tests, so I have no idea. I don't even know what's on them. I would imagine that your teacher probably has study resources. If not, there's got to be like Khan Academy or like YouTube channels that are dedicated to this. Why do people think nukes are fake? Because they're dumb. No, because they just don't want to believe anything that anything tells them. Do you think the universe will contract or collapse? I I'm kind of agnostic on the issue, but the reason why I'm interested in studying it is because it's gone pretty unstudied in the last 20 years just because of the discovery of dark energy. And so I think it's like an interesting way to go. Interesting way to investigate. Why couldn't an FTL craft work? Trivial to invent physics that could make it work. There's no reason. Oh, this is. There's no reason to even suspect it's not possible. It's not different than saying the AB effects are impossible. Well, look. I mean, like the current way that we understand that FTL craft could exist is by something like an Alcubierre drive, but the matter required for Alcubierre drives seem to require negative mass. You need to have matter that has negative mass, and that doesn't seem to exist. Can you share cool facts about W bosons? I know they mediate beta decay as a virtual particle and have a charge. Do they interact with electromagnetism? What does it mean that they mediate as a virtual particle? So first of all, they're like as heavy as an iron or as a silver atom, which is kind of weird that like a fundamental particle is as heavy as like a whole big atom. They do interact with the electromagnetic field because they are charged. So for example, you could in principle bounce light off of a real W boson. And when we say that it mediates beta decay as a virtual particle, what this really means is that it's the W boson field that interacts to mediate beta decay. The virtual particle just means that it's actually a field configuration that doesn't have a particle-like description. From Will Day with the $5, my grandmother passed away sadly. I loved her very much and I'm going to miss her so much. Thank you for all you do, Blitz. It brings joy in a hard time. Will Day, I'm sorry to hear that. My condolences. I wish I could say that things will get better, but they don't. You just learn to live with the suck. But you know, best wishes for you and your family. That's sad. Sorry to hear that, bud. Do you believe the ghost murmur is real? No, and I made a video about why we know it's not real. Why are all these particles hiding? Which particles are hiding? There are particles that like we think might exist, but we haven't found yet, and that's just because who knows? Maybe they don't exist, or maybe they're just hard to find. The Alcubierre drive does not need matter in the fuel sense. No, it's not in the fuel sense, it's in the configuration sense. What do you think about CPT symmetry? I have a personal theory that explains dark matter, antimatter to matter ratio and more. Well, okay. Submit it to a journal. Are we doing guests today? We will be doing guests in about 50 minutes. How can the universe expand at an accelerated rate if there's enough matter to contract it? Well, that's what dark energy is for. That's what dark energy does. In fact, that's how we hypothesize dark energy exists to begin with. Hey, I heard the Big Bang is no longer the most accepted theory. What is the new theory? No, the Big Bang is still it's still the scientific consensus. It's just not believed to be the beginning of the universe. Not the consensus is not that the Big Bang is the beginning of the universe. Not that the Big Bang is wrong, just that it's not the beginning of the universe. Why is dark matter invisible to us? The kind of particle that it is seems to not interact very much with the kind of stuff that we're able to detect. How do we know that quarks have color charge? Well, they're kind of defined as things that have color charge. We constructed a theoretical model called quantum chromodynamics, or more specifically, like SU3 Yang-Mills, or not more specifically, perhaps differently, SU3 Yang-Mills. And that theory really well describes what quarks seem to do and what hadrons seem to do. And one of the implications of that model, if it's true, is that quarks indeed have color charge. So it's more that like we have this model says that quarks have these certain properties, and that model also makes really, really good predictions about the world around us. Can life come from non-life? Seemingly, yeah, but you'd have to ask chemists about that. Least Molin parent-child universe, could energy in the body of an astronaut that goes into a black hole become the Big Bang of a new universe? Least Molin, so I know what you're talking about. It's called cosmological evolution. That's the name of, or cosmological natural selection, rather. It's the name of the theory. In principle, like anything that falls in contributes to the Big Bang of the child universe, but that model or that theory seems to have fallen on hard times because it would imply certain things about our universe which don't seem to be true. How much do you cross over and research on quantum computing? Basically none. Basically none. Jump down to the bottom. I will be on the line at 6 p.m. CT today. That is true. I will be. Thank you for the reminder. Is it more likely that consciousness is material or immaterial? I lean towards material, but, you know, other people disagree. Could you explain Hooke's law? Yeah, Hooke's law is merely that for an idealized spring, the strength of the pulling force, if you're stretching it, or the strength of the expansion force, if you're compressing it, is proportional to how far away how far the length of the spring is away from its equilibrium distance. Let's jump down to the bottom. Oh, watch the DESI and JWST, they're revealing a lot. Yep, I remember I made a video on the DESI data. I actually made 2 videos on the DESI data. Yes, I am on with Matt tonight. That is true. I had forgotten as well. Parker wants you to join his live. Is Parker talking to a flat earther or something, or? Well, I'm doing this. Parker will have to, you know, unfortunately, he'll have to wait. I'm not going to end the live stream just because Parker wants me to hop into his. How does using Green's theorem help solve physics problem? Well, look, it's a mathematical result, and that mathematical result has nice applications in a lot of places. Green's theorem is basically the divergence theorem, so anytime that you're computing the integral of a divergence, it's handy. From Oxrixnix with the $10. Thanks for answering. I should have super chatted the first time. No, you're good. You're good. Parker requests your service. I understand. I'm not ending the live stream though. I'm not going to end the live stream. Just like this is when I do my live stream. From Demtro with the $20. Thank you so much, Demtro. What are your thoughts on Earth becoming a Type 1 civilization and eventually a Type 2 civilization? Why or why not could we ever achieve it? So generally my view is that like this Type 1, Type 2, Type 3, whatever civilization stuff, that I think it's generally like, I'm not particularly interested in it. I don't think it's a useful metric because civilizations are not just about energy consumption. That said, to answer the question directly, becoming a Type 1 civilization means taking advantage of all of the energy available on the Earth, right? Or is that all of the energy available in the solar system? And you know, that is capable of harnessing all of the energy available on the home planet. So like we are not so far removed from that, but we would need tons and tons of solar panels all over the Earth, right? But yeah, I mean we're actually pretty good at harnessing the energy available on the Earth. Type 2, I guess, is the Type 2 is the one where you harness the entirety of the solar system, right? And so that's thousands of years off, I imagine. Yeah, I mean, arguably in some, like, we don't have solar panels all over the Earth, so like we're not going to be Type 1 ever, but we're very, very close. In that, like, we basically are using solar energy that landed on the Earth a while ago. That's what burning fossil fuels is. If I was on a planet and there were 2 identical spaceships with different speeds, whose fuel was connected magically to a tank in the planet, does it take more fuel to accelerate the one closer to C? On a planet and there were 2 identical spaceships with different speeds, fuel was connected magically to a planet. So to increase your speed by 1 mile an hour, yes, it takes more fuel to do that if you're closer to the speed of light than it is if you're further from the speed of light. Wouldn't it be more efficient to put solar panels in space to maximize gain on Earth overall? Yeah, probably. Can light be slowed down? In a sense, yeah, just put it through glass or water. Closed time-like curves are really weird. Do they fascinate you? Yes, they do. What's new in quantum communication? The military are investing in it, but not to public. I don't even know if that's a question. To be honest. How does field mediation work? Usually the forces only interact with their own fields. Why and how does energy jump from one field into another as matter? What determines which fields they go to? Well, look, so like anything with charge interacts with the electromagnetic field. So the electromagnetic field can interact. I mean, like, you know, Newton's third law. If object one can impose or if an object with charge can change the momentum of the electromagnetic field, then the electromagnetic field can change the momentum of an object with charge. And it's similar for the W and Z bosons and gluons as well. Do you play KSP? I used to. I haven't played it in a long time. If I was an astronaut in space, in a spacesuit, and I touched another astronaut and then farted, would they be able to feel the fart vibrations? Yeah, probably. As long as it was intense enough. Oh, sorry. Why am I tired? Also, hi. Sorry, I'm also tired. I want to know how many of y'all I just made yawn, by the way. What are your thoughts on baloney? I used to be a fan. I'm now less of a fan. If you had a string connected to a rock and you connected to a rock on the moon and you pulled it, is that faster than light? No. Can you do a stream playing KSP? I mean, I could, but I haven't played KSP in forever. How intense would the space fart need to be to vibrate the spacesuit? Look, I don't know. Do the math yourself. Is gravity theoretical or fact, and how is it measured? We know things fall, but does it prove gravity? Gravity is a few things. It's a fact in that there is a phenomenon that we call gravity, which is the phenomenon of mass attracting mass and of mass bending light and things like this. Then there's the universal law of gravitation, which was Newton's empirical formula that he derived. This is the one that has an inverse square law. It's that one that was derived by Newton. And then there's a theory or model of gravity, which was proposed by Einstein. This is called general relativity. So it is a fact. It's also a theory. It's measured directly using things like the gravity probe, the gravity of probe B experiment, and various high precision Cavendish type apparatuses. So yes, it is a fact. It's also a theory. Can you explain the Yang-Mills existence and mass gap problem? I know it's a millennium problem, but I don't understand how it's connected to physics. So the way that we describe forces, at least the quantum forces that we have access to, like quantum chromodynamics, this is the strong force, and the weak force, which is SU2, and then the electromagnetic force, which is U1. The way that we describe these is with a mathematical structure called a Yang-Mills gauge theory. A Yang-Mills gauge theory is basically kind of like the generalized version of what field theory can be. You know, these are things with inverse square laws and so on and so forth. So at least, you know, inverse square laws and wave propagation in the normal way and so on. So when we talk about the Yang-Mills existence and mass gap problem, the question is if you have a Yang-Mills type of force, whatever it might be, you know, the strong nuclear force, which is SU3, or it might be SU2, which is like the weak nuclear force, or you might have SUN, which is just a generic force with n types of charges, whatever it might be. The question is that if you have a non-trivial, this is a non-abelian Yang-Mills theory, then that means that the field can interact with itself. That's roughly what non-abelian means in a physics context. And so what that means is that you can have the field producing bound states of particles, bound states of, you know, kind of the field clustering up and forming like a knot or something like this, which is just in the language of particles, this would be like, for the strong nuclear force, it would be like a whole bunch of gluons binding themselves together into a particle. So the existence and mass gap problem is merely, can we prove that such particles can form, and like just using the machinery of Yang-Mills theory, and can we prove that there is a minimum mass for such a particle? Namely, it doesn't have any, that the mass of a particle can't get arbitrarily close to zero. That's what the Yang-Mills existence and mass gap problem is. Hopefully that answers the question. Could I work at LIGO with a master's in gravitational wave physics? Maybe. You could at least work there as a grad student, like apply for a PhD and then working with somebody who works there. What are your thoughts on why hot water freezes faster than cold water. I mean, I don't know if that's generally true. It's true in some scenarios, but like if you put a pot of hot water on the stove and you put a pot of cold water on the stove, I don't think it's, or sorry, in the freezer, I don't think it's true that the hot water will freeze faster. I know it's true if you like fling it in the air or something like that, but I don't know if it's true like generally, because Newton's law of cooling would suggest otherwise. How many people in the history of physicists have cured? Correct answer is 0. Physicists aren't physicians. What? From Uncertain Path with the $5, is there a response to the claim that DESI data doesn't support deceleration, only a reduction in the speed of acceleration, i.e. no big crunch? DESI data is currently, so the DESI data is consistent with reduction, or DESI data is consistent with accelerated, with negative jerk, let's put it that way, which means that the acceleration is decreasing. Now, that is consistent. That doesn't mean that there's no big crunch. There are models that will have a big crunch in the future that have, you know, decreasing acceleration now. And there are models that won't have a big crunch in the future that have decreasing acceleration now. But what it does mean is that our assumptions, if the DESI data is correct, if the dark energy is indeed dynamical, what it does mean is that our assumptions about how the universe would evolve in the future are now in question. Are there closed time-like curves? Does this mean time travel is possible? It seems like I would be very, very skeptical if there were like particular places in space that have closed time-like curves, unless the entire universe is a closed time-like curve or a closed time-like thing. Do you follow Ken Wheeler at all? No, I don't know who that is. Oh, wait, no, that's Kenneth Wilson is who I'm thinking of. Who's Ken Wheeler? Seems like he's nobody. I guess he has a YouTube channel, but he doesn't, it seems like he's not like an important scientist. Are you religious? No. Can we catch subatomic particles while being donated, stopping them mid-drop? I don't know what the rest of the question is. Is it true that a gluon field can interact with itself? How does that make sense? Yes, and it's because gluons are indeed charged under their own, charge. Gluons have color charge in the same, well, in a different way than quarks do, but they do have color charge. Wasn't the Higgs boson like a bogus particle anyway? Doesn't actually mediate anything, just represents the field and decays. The Higgs field mediates, or the Higgs field is the source of mass for most fermions, and for the W and Z bosons. So it's not a bogus particle. But if you want to prove that the field exists, one of the ways to do that is to produce a field excitation, i.e. a particle. What is the mechanism by which celestial bodies distort spacetime? The stress energy tensor is proportional to the Ricci tensor. That's the mechanism. That's the way it happens. If you mean something else, then I don't know how to answer your question. Hey Blitz, is the beginning of the universe to be misconstrued with the expansion, and was there one? So we don't know if there was a beginning of the universe. What we do know is that our universe was very, very small 13.8 billion years ago and is now much bigger. Does the Higgs boson mediate anything then, or just a byproduct of field distribution? Well, look, the Higgs boson can interact with things. If that's what you mean by mediate, then sure. If you mean, does the Higgs boson affect the covariant derivative, that is what we mean when we typically mean that there is a force being mediated. No, the Higgs boson is not a force carrier. But the Higgs boson can interact with things in the same way that, like, the top quark can interact with things. What is your research on? If you want to find that out, go to my website, blitz.phd. It's mostly on conformal geometry with a bit of general relativity and cosmology and quantum gravity thrown in. How do I explain to someone that they are not allergic to magnets? Well, you could hide a magnet somewhere and then see if they sneeze, right? Can two Higgs bosons bind together? No. I don't think so. Do you find it weird labeling the color charge the charge color charge since they aren't photons? No. The reason why that's called color charge is just because the behavior, like the way that they combine with each other to get like to neutral charge kind of behaves like the way that we think of color combining. Like if you have combined red, green, and blue, you get white out. We know the shape of the universe. We don't, but the best guess, the data is consistent with the universe being flat. It's also consistent with the universe being positively curved, which tells us about, you know, how the universe will evolve in the future. Why does the standard model Lagrangian look like just addition and multiplication? Is there advanced math behind it? And if so, where is it hidden? Well, it looks like multiplication because, I mean, there is addition, obviously. There is also multiplication, but a lot of the objects are not single numbers. They are tensors, and a lot of the objects are operators. Well, yeah, okay, so all of the objects are operators. Some of the objects are differential operators as well. Yeah. What's baryonic acoustic, or you mean baryon acoustic oscillation? That's what it's called. Basically, in the very early universe, you had fluctuations, and those fluctuations, you have fluctuations due to quantum mechanics, basically, like high density and low density areas. And so those fluctuations, because they're high density, they would push out, and then gravity would pull them back in, and so you'd kind of get like this oscillatory behavior. And as the universe expanded, those kind of pushing out phenomena from those fluctuations kind of froze in place. And we can detect where the high density regions froze in place and how big they were when they froze in place by looking at the distribution of galaxies, because there's more likely to be more galaxies and more matter where the high density regions were. Oh. God, why am I don't know why I'm so hungry. Oh, I'm sorry, everybody. Do physicists struggle with advanced math, and do mathematicians struggle with physics? Not necessarily, and not necessarily. How is it flat and curved? Well, look, it's either flat, like either the universe is spatially flat, or it's spatially curved. We don't know which one it is, but the data is consistent with both. Could we predict what a time-stable Higgs boson fluid would look like? I don't know what that means. From Sunapeak with the 25 AED, I don't remember what that is. As a physicist, why do you think you're so hungry? I had the same breakfast that I usually have every morning, but I also got up earlier, so that's probably why. So I ate breakfast earlier and so on. How would many worlds interpretation fix locality? Every possibility would split an entanglement? Yeah, basically, that's roughly it. I mean, it's not that it fixes locality, it's just that there's no collapse involved at all. So there's no violation of locality happening. It's just if you have two entangled things, then they're in the same, they're in the same world. And you have worlds can be correlated with one another, but it'd feel kind of invasive to disregard their allergies, so I'd rather convince them with theory. I mean, like, you'd have to go talk to biologists then. What is more important for physics, theoretical understanding or practice? They're both important. From Sunapeak again with the 25 AED. No, explain it in moles and Planck's constant. No, I refuse. Oh. Sorry, I'm going to jump down to the bottom because I'm a bit behind. Entering a black hole warps time in a way that takes all things to the end of time. It doesn't. It's not what entering a black hole does. How do flat earthers explain eclipses? They usually don't. They usually just want to pivot and say, yeah, but water can't be flat, or water can't be curved around a spinning ball. That's just what they tend to say. Will fusion reactors be common in 20 years? Look, people have been saying that for 50 years, so who knows? How can particles also be waves simultaneously? Because particles are just a kind of wave. Opinion on supersymmetry. Well, it was hoped that supersymmetry would be found at the Large Hadron Collider, but it wasn't, so now there's probably less reason to think that supersymmetry is real. Is it possible to establish true randomness? It seems like a logical fallacy to conclude that because a causal mechanism hasn't been identified, there just must not be one. Well, look, if you trust quantum mechanics, then yes, true. If you trust certain interpretations of quantum mechanics, then true randomness does exist. How can you prove true randomness? I mean, what you can do is you can take data and you can say that whatever this is, it's indistinguishable from true randomness. From Sunapeak again with the 25 AED. What is United Arab, or it's United Arab Emirates dirham? That's right, I knew that. Many world theory implies there's a Blitz PhD who believes in God. Now I'm imagining the two Blitz in an endless debate on God. Well, so no, it doesn't imply that. It just implies that those things that arise from quantum splitting events, or those macroscopic worlds that arise from quantum splitting events exist, which doesn't necessarily mean that all possible or all conceptually possible worlds exist. That depends on whether or not the things that cause the brain to be the way they are rely on quantum mechanics or not, basically. Change from an atheist and political channel to this. So, no, it's not changed. I just do this twice a week. I have many hats. So, I don't know if you've seen the videos that I post are science communication. I do Ask a Physicist on Tuesdays and Wednesdays. I do atheist content usually on Thursday or on Fridays and sometimes Thursdays. I do flat earth content on Mondays. And I do, these are live streams, and I sometimes do political stuff on Thursdays. So I hope that answers your question. God, my stomach is so rumbly. Forgive me if this is not your specialty. Do we know what is inside the sun? Yeah, it's mostly hydrogen and a bit of helium. So why can Hawking radiation escape a black hole but nothing else can? So Hawking radiation, the best way that I've heard to explain it is that it's essentially something quantum tunnels from the inside to the outside, like a particle or a wave. Why does the length of a lever arm impact torque? There's actually a really good video on this. I think it was, is it Steve Mould that did it? I think it's Steve Mould. Or no, maybe it's Veritasium. No, I'm sorry. It's Vsauce. That's who it is. Is it? I think it's Vsauce. There's a, or maybe he never made a paper about it. Maybe he just or made a video about it. Maybe he just referenced a paper. Let me see if I can pull it up, because yeah, here we go. This is the paper. If I think that this is the right one, yeah, okay. So here's the paper. I'll just show you it, and you should read it, because it's kind of involved actually, to explain why like how torque works and why it has to do with lever arms and stuff. So this paper is freely available. Just Google the physical origin of torque and the rotational second law, and you'll find it. It is fairly involved though. Like it's not complicated, but you have to be careful. You have to like think carefully in order to, actually make sense of what's going on here, which is surprising. Most people don't know that. From Grimmy with the $2, many hats. Where's your wizard's hat? I don't own a wizard's hat. And from Simeon Urchin with the $2, no question, excited to see you later on the line. Well, I appreciate that. Do you know Simon Dan? Not personally, no. Let me just make sure it was, see if I can find a question. In many worlds theory, then how do the entangled particles know about each other without FTL non-locality? Well, they're correlated, right? There's a world where one's up and one's down, and there's a world where one's down and one's up, and that's it. Those are just the worlds that exist. They don't know about each other. Those are just the possible worlds. No way Veritasium's a trumper. No way. Hold on, is that true? If that's true, I'm so disappointed. Um, okay. No, I don't think that he's a Trumper. Yeah, I don't think that that's true. At least a you know, a cursory search. Do you think black holes could actually be wormholes? No, I don't. Host is so smart, he's on TikTok. Well, yeah, this is part of my income. You seem upset by that. I don't know why you would be. You don't have to watch though. So, isn't he Australian? Yeah, but like, I mean, there are Australians who support Trump, for example. Is reincarnation real? Is there no scientific evidence to support it? Look, I haven't looked deeply into it. I'm sure that some people will say that absolutely reincarnation is real and there is scientific evidence for it. It doesn't seem like it's consistent with the way that we understand physics and biology. Remember when you almost failed half your class? Well, no, it wasn't half my class. It was 40 students. But yeah, I only ended up failing like 11 or 12 of them because they were repeat offenders. The rest just got doctor letter grade. But yeah, I mean, if you cheat, then you're going to, and you get caught, there are going to be consequences. If neutrinos are analogous to a rain that has extremely weak interaction with vacuum, have physicists investigated whether neutrinos influence anything at all, potentially even extra dimensions? Those things seem uncorrelated. Neutrinos are very well understood, with the exception of their mass. We don't understand where their mass comes from. And people think about all sorts of crazy ideas to try to explain why their mass is what it is. But aside from that, like, there's not much else to explain. You should consider playing League 6 and OSRS. It's really fun. I don't really have the time to. And I never got into OSRS. Do we know why black holes exist or what's their purpose? Well, they don't have to have a purpose. Like, as far as we can tell, nothing in our universe has a purpose. But black holes exist because some stars are very, very heavy, and then at the end of their lives, they explode, and then what's left behind collapses into a black hole because there's nothing keeping them up anymore. That's the reality we live in. What is their mass? We don't know what neutrino masses are yet, but we know that at least 2 of the neutrinos have non-zero mass. Thoughts on black holes described as fuzzballs? I think I have a video on this actually. It's a neat speculative idea. We don't have any data that supports it yet, as far as I know. Your family must love you cooking for them all the time. I am not a skilled cook. My wife definitely wishes that I was, but I'm not. What are the most important statistical ideas invoked in physics proofs? Probably the most important idea, and this happens, and by the way, the physics proofs that's saying something, right? Not a lot of physicists are doing proofs, but there is this idea that you can average, that you can describe a system, that you can describe a system effectively. This is in the language of effective field theories, by basically doing a specific kind of averaging, and that's probably the most important idea that's come out of statistical physics. Is this? It's related to this idea of renormalization. Which is essentially kind of coarse-grained averaging, or coarse-graining averaging. Do you have to be good at math to be a physicist? Basically, yes. There are probably a few exceptions, but basically, yes. Doesn't the Higgs boson give mass to the neutrino too? Not as far as we can tell. No. It seems like that there should be a different explanation for the neutrino masses. Do black holes just expand infinitely? No. They don't expand on their own. Stuff has to fall in them in order for them to gain mass. There's evidence for black holes, no proof though. I mean, there's proof in as much as there's proof of anything that exists in space, in that we have pictures of them. We have pictures of them. We have like a whole bunch of indirect evidence for them. Like, that seems like as good proof as anything. Are you taking live guests? Yes, I will be taking live guests in about 20 minutes when I switch over to a members only chat, so everybody will be able to watch, but only members will be able to ask questions. Members and super fans, you know, all of that stuff. For a math degree, would chemistry or computer science be a more beneficial option for A-levels? I don't know what A-levels even are. I know it's a British thing. I don't know. Maybe computer science would be my guess. What is holding black holes together when a star explodes? Why doesn't it spread like a bomb? Well, so what happens is that you have basically a collapse. It's collapsing because the gravity gets so strong. And then the explosion happens when the collapse bounces off of a hard core. And that hard core then that bounce basically expands out. And if things go correctly, it bounces off of the hard core, it slows down, and then a whole bunch of neutrinos are emitted, which heats up that expansion and causes an explosion. But there's still that hard core left over, and depending on whether or not more stuff falls onto that hard core or not, you're left with either a black hole or a neutron star. From Josh P with the $2, can we reverse gravity like a white hole? White holes almost certainly don't exist, and so no, white holes also don't reverse gravity, even if they did exist. What did you do your PhD research on? So you can go read about that on my website, go to blitz.phd. But just to summarize it, I did it on conformal hypersurface geometry with applications to the ADS-CFT correspondence. This might be a nonsensical question, but why does gravity arise from mass, or is it the opposite? Look, I mean, this is not a question that physics is really capable of answering. Physics is not in the business of answering why questions, at least not often. You could ask the same thing, like, why does light arise from moving charges? Well, it's just a thing that happens. I can give you a formula for it, but why? It's not a physics question. From Darth Smack with the $5, why does the square block not fit into the circle hole? Well, it does, you're just not trying hard enough. Is it hard to get a master's in physics? I had a fairly straightforward time. I'm sure some people in my cohort had a hard time, but I also wasn't very social. So did you do a straight to PhD program? Yeah, I did. From September Timber with the $2, or September Tamber with the $2, gas container law for flurfers. F equals G times M1 times M2 over R squared. Yep. That is the gas container law. Is light an emergent property? I mean, in some sense, it emerges from the electromagnetic field. But you know, it's kind of like a fundamental aspect of that field, so. Dumb down string theory for me. String theory is the idea that instead of having, and this is the dumbed down version, instead of having all these different subatomic particles, you just have subatomic strings, and the way that they vibrate, the different ways that they vibrate correspond to different particles. That's basically it. I mean, it's obviously way deeper than that, but that's kind of like this fundamental idea. Mindos, thank you for becoming a member at level 1 or something. I think that that's what just happened. Welcome to 1. Appreciate that. Is gravity a force in our reference frame? Which reference frame? In our reference frame, yes, absolutely, it's a force. In the reference frame where we're stationary, it's definitely a force. But we are also not in an inertial reference frame. So in an inertial reference frame, there are no forces, or no gravitational forces. From Afer Brennan with the $5, I think the real question is, does gravity come from mass or the other way around? Oh yeah, gravity comes from mass. I mean, at least as far as we can tell, mass is not something that gravity makes. How the frick do I become a member? It's a YouTube thing. Is time a human construct from Josh P? In some senses, yes, but there is definitely some temporal aspect of our world, of the world that we live in, that is independent of human thought. In the same way that, like, in some sense, like, distance is a human construct, because, like, you know, the way that we measure distances, the way that we think about it, but there's still a spatial component of the world that we live in. How does the law of entropy impact your opinion on the Big Bang? It doesn't. The law of entropy it's not a thing. You're thinking of the second law of thermodynamics, but the second law of thermodynamics seems like it's not really pertinent to a lot of cosmology. Do physicists learn quantum chemistry like chemists have to? I didn't. Why is the universe expanding faster when it first started than when it first started expanding? There seems to be this thing called dark energy. And that's we say, well, it is doing this thing. The explanation, well, we don't know what it is, so we'll call it this. We'll be handling a class for the first time tomorrow. Wish me luck. Good luck. Somebody asked, why do you call gravity a force? Why do you say gravity is a force? I've been corrected many times about this. You've been corrected by people who know just below the surface, but don't go any deeper than just below the surface. Gravity is definitely a force in the same way that the strong nuclear force is a force. Gravity comes from a curvature, as do all of the other forces. All of the other forces involve curvatures of spaces, or in gravity's case of space-time. They are just curvatures in what are called associated spaces. And whereas gravity is a curvature in the tangent bundle, but they're all curvatures, and gravity can transfer momentum just like a force can. That's what, in some sense, that's what defines a force. It's something that causes a change in momentum, and gravity can do that. So gravity is a force in as much as the other quantum forces are forces. Anybody who says otherwise hasn't gone deeper than just below the surface. What is hypersurface geometry? It's the geometry of hypersurfaces. So a hypersurface is a specific kind of object that lives in certain kinds of geometric spaces. Well, in all geometric spaces, you can have hypersurfaces, but it's a specific kind of object. And so as part of a lot of what I do for my research is I study that geometry. Cotangent bundle, yes, it is cotangent bundle curvature too, because there is a metric that relates the two. Have we ever seen or recorded, detected a wormhole, or is it just theoretical? It is just theoretical, and it probably doesn't exist at all. Can Alcubierre warp drive be possible without negative energy or immense energy? Seemingly no. How's the job market? Terrible. Is Super Chat a TikTok thing, or it's another platform? It's a YouTube thing. From Helium Biscuits with the $2, Ian says no change without time versus Hartle-Hawking. So Ian's referring to like a philosophical notion of time, whereas when I'm talking about time in the space-time sense, it's not a philosophical notion, it's more of a physical notion. So there's just a degree of equivocation happening, but Ian is careful not to actually do the equivocation. From Lydia Pacheco with the $5. Applied math major taking my first physics class next semester. Do you have any study tips or content creator recommendations that might help? I don't know what class you would be taking. Study tips? Okay, so this is annoying, but do the exercises, right? And if you don't know how to do the exercise, go look at the answer for the exercise and try to understand why the answer is, or go look at the solutions and try to figure out why the solutions, which will tell you how to do it usually, why that method worked, and then go back and do more exercises. From Josh P again, is Laplace's demon concept possible? No, for kind of two reasons. One, quantum mechanics makes it impossible, but the second, perhaps deeper reason is that they're potentially uncomputable things that would require an oracle that cannot just be computed merely from, with a sufficiently powerful computer. Are you religious, and do you think most physicists are religious? I'm not religious. I think that most physicists are not, or it's at least like roughly 50-50. Can you explain what a one-form is and how it relates to differentials? A one-form is, well, it's a kind of object. It's a kind of algebraic object that lives geometrically. In some sense, it's the kind of thing that takes in a direction and spits out a number. This is by definition what it is. It takes in a vector and spits out a number. At least that's one way to think about it. It's a covector. Another thing that a one form is it is a small amount of something. Another thing that a one form is that it's just equivalent to a vector if you have a metric around. So I do have a video on what differential forms are. It's from a long time ago. Maybe I should remake it. But as far as I know, there's not really like one geometric interpretation of what a one form is. There's like, they show up in kind of a lot of different contexts. Do you think a fourth spatial dimension exists, or is it just 3 dimensions plus time? I do not think a fourth space. Well, okay, I'm agnostic about it. I kind of lean against it because I don't see any evidence for it. Which university did you go to? So I went to UC Davis for my grad school. From LCP L Morbid with the $2. Can you explain the diagram in your background? Yeah, so it's referring to, well, if you're on vertical, it's here. If you're on horizontal, it's here. This diagram is just depicting electron scattering. So we have 2 electrons coming in. They're, again, if you're on horizontal, they're the legs at the bottom. The legs at the bottom with the arrows coming in. Those are 2 electrons coming in, and then they interact via some complicated process, in this case exchanging a photon. That photon becomes an electron-positron pair, or a fermion-antifermion pair, and then it becomes a photon again, and they bounce off of each other. From Joshua Phillip with the 5 Canuck bucks, trying to think of research directions for grad school and beyond, but getting FOMO. How locked in are you to a direction, say biophysics versus nuclear? To a degree, you are pretty locked in, yeah. You're not locked in until you know, maybe your second year or so if you're in the US system. But there is there's a reason why it takes so long to train grad students to become effective researchers, and it's because it takes a long time to learn that subfield. So I can understand the feeling of FOMO. All right, let's skip to the bottom because I'm a bit behind. Oh, I popped my back for the first time in weeks, which is nice. $20, or sorry, 20 pounds from SS1 with SS1 XXX. Hi, I'm in university for politics, but I've always been interested in science, specifically physics, but I'm unfortunately stronger in humanities. But your content feels like I'm back in my physics class. Love what you do. Well, I appreciate that. Very kind of you. And from Josh again with the $2, I thought time was the 4th dimension. Time is a dimension. So in total, there's 4, but it's not like, there's not really a way that you can order the dimensions. Does light have mass? No, it does not. Can an exploding star leave no core behind? Not as far as I know. I mean, the way the explosion happens is that it bounces off of a hard core. So if there's no hard core to bounce off of, then it seems like that there couldn't be an explosion. What's your theory on why Methuselah's star could be older than the universe? Well, it's not older than the universe. That's just an incorrect dating. I just calculated the age wrong. How can light not have mass if the photons generating the light contain mass? The photons don't have light either. Sorry, the photons don't have mass either. Dr. Blitz, can you explain what an axion field is? Yeah, it's a hypothetical or perhaps theoretical kind of fundamental particle, which is used, so at least in my field, it's used a lot to explain dark energy. If I remember correctly, the axion model comes from a PQ symmetry, or a PQ symmetry, I think is what it's called. It was originally proposed to try to explain why why there is no CP violation in the strong nuclear force. And basically there's a parameter that is either 0 or very, very close to 0, which they promoted to a particle. And it basically becomes like an angular variable. So it kind of like goes in a circle, so axion. And then you can do the quantum field theory for it. But it's basically a proposed kind of particle that has certain properties. It's related to the strong nuclear force and also could be dark matter. Or sorry, it could be dark energy. Could be the cause of dark energy, rather. How did a celestial body the size of Mars impact Earth without becoming a planet itself? Well, it would have been a planet, and the proto-Earth would have also been a planet, and then they smacked into each other. Why can't an infinite supply of fuel accelerate a spaceship beyond light speed? Well, because every time you burn, say, a ton or a kilogram of fuel, the amount closer that you get to light speed gets smaller. So regardless of how much fuel you burn, you will never get to light speed, so you certainly will never get faster. Can you explain the SU5 equals SU3 cross SU2 cross U1? I know it blends all the fundamental forces together based on their representations, but I'm also confused as to those representations. So look, the SU5 equals SU3 cross SU2 cross U1, that's just like a mathematical fact. And it's a nice fact because SU5 is in some sense the smallest special unitary group that contains all of the unitary groups that are required to represent the standard model of particle physics. So this was like a proposed explanation for how you could unify the three quantum forces that we know about. And, you know, it captures all of the relevant representations. As you mentioned, these are the kind of different kinds of fundamental particles and charges that those particles would have. But the trouble is that it also makes a whole bunch of predictions about other particles that should exist. There are other representations that aren't captured by any one of these. And those don't seem to exist. So it seems like SU5 is, perhaps it's not ruled out, but it at least isn't, at least we don't have strong evidence to think it's real, to think it's like an actual symmetry that our universe has. I'm also a physicist. I like what you're doing here. I have a friend who's constantly asking me if faster than light particles can exist. What is a short answer other than no? Well, no is going to be the shortest answer. You could say no. Okay, so what's the right way to explain this? On the one hand, you could just like construct some model that has faster than light particles in it, I guess. I saw a paper do this fairly recently. It was called like In Einstein's Basement or something like this. But like there's no evidence that supports that model. So you could say no, there's no reason to think that they exist. Which means that there's no data that says that they do. There's no theoretically justified models that imply that they do. So maybe that's the best way to do it. What is space-time fundamentally made out of? It seems like it's made out of space-time. As in, it doesn't seem like it's made out of anything smaller. Do you think many worlds interpretation can ever be falsified? It seems like you can have arbitrarily many interpretations, so they can't all be falsified. Well, yeah, it could be falsified just by verifying some other interpretation, right? As a smooth manifold, do physicists think of the space-time as Euclidean, i.e. as R4? For the most part, yeah. How relevant is string theory in modern research compared to how common it is in popular media? It's far less relevant in modern research than it is in popular media, but it is still pretty relevant. It's just the media like way overblows it. Oh, sorry. All right, let's skip down to the bottom. Why do supermassive voids like Boots void happen? I imagine that it's just because those voids are the result of quantum fluctuations, quantum density fluctuations in the early universe that happened very, very early, so they had a lot of time to expand. That's my guess, but, you know, who knows? Do you think our species is stupid? No. I don't think that we are like the most brilliant things to ever in principle even possibly exist, but no, I don't think that we're stupid. Will AI replace your study? I mean, who knows? Impossible to say. Isn't string theory a broken model? No, it's actually consistent. That's the problem. If light is not a mass particle, is it radiation? Well, light is a particle, it just doesn't have mass. At least you can conceptualize light as particles. All right, y'all. So what we are going to do is we are going to, and I know that this is going to be disappointing for a lot of people, but what we are going to do is we're going to change over to only members and superfans being able to send messages. Now, I know that there's a way to do this. Members. So we're transitioning over. And I don't know, can I set this up on... I might have to end the live and then restart the live on YouTube. Everybody will be able to watch, but I'm going to restrict who can send messages just to followers or to... yeah, I have to restart the live. I'm going to restart the live on TikTok. YouTube will just continue on through, and I will be taking guests as well. Usually I would end the live here, but, you know, I extend the live so then you guys can have a little bit more content, right? Sorry, I just have to send this to participant mode members. And I'm going to restart the live on TikTok. So I'll see you in a second. Everybody will be able to watch, though. It means I'll get to the questions more quickly. And there we go. Now so I will be taking guests. Maybe I'll only be taking guests through TikTok, or I actually don't know how I'm going to do this. Yeah, I don't know how I'll do this. Oh, yeah, how am I going to filter guests through TikTok? There are two different YouTube streams. Both of them are members only, yeah, or members only contributors. Yeah, I'll take guests through TikTok. I don't know if... Is there a way to set it so that only members can request? Is there a way to check? I don't know. Never done this before. But we have our first, we have a super chat, and we're not only taking super chats, but from Helium Biscuits with the $2, what's its claim of MMX fringe shifts at altitude? That's according to Dayton Miller, but Dayton Miller famously didn't account for temperature fluctuations in his instrumentation. So, question in regards to space expansion, if we can't directly detect, oh, I should, one moment. I need to do this. There we go. If we can't directly detect it in action, we can only detect it via the velocity of moving masses. Yes, that is true. From Demtro, how do I get to see the debate notes? You will see the debate notes from, if you go to your membership thing on YouTube, there should be like a link to the debate notes. Only take guests from TikTok? I think so. I don't know how else I'm going to filter members only. In fact, I don't even know how to check to see if the guests on TikTok are members only. Well, let's take a guest. I don't actually know how to see if somebody's a member when I'm trying to take them as a guest. If you had to lean towards the graviton existing or not existing, which would you choose? I would lean toward it existing. Anyone could join on Discord. I think anyone can join on YouTube as well, or on TikTok as well. That's the thing. But we'll just accept a guest. We'll take a guest from Sir Xavier. Oh, and he didn't come up. That's fine. Want to make sure that... Yeah, okay. Well, welcome everybody. As you heard, my stomach is very rumbly, so I'm gonna eat a Oreo really quick. All right, we're good. Yes, my stomach is very rumbly because I'm hungry, which is unfortunate. But welcome everybody. This is a new thing I'm trying. I don't know how successful we'll do it. It is an added bonus. Usually the live stream would be over by now, but I'd rather, you know, I have time between 10:30 and noon. And so maybe this will encourage more people to ask questions and to, support the live stream. Would you mind posting your streaming equipment setup in your Discord? I could. It's just a mic. It's a HyperX Quadcast, whatever. And it is and then I have a computer. That's it. I suggest you do this mainly because AI models tend to prior. Okay, that's not a question for me. So yeah, if you guys are a member, if you guys are a super fan on YouTube, if you guys are members on, sorry, if you are members on YouTube, which is $4 or $5 a month, or super fans on TikTok, which is like $4 a month or something like this. Feel free to ask questions and I'm happy to answer them. This is the standard game. I know that there are significantly fewer members than there were back in the day when I was pushing it hard, but this will hopefully be an incentive for you guys to become members and become super fans, because then you get an extra hour and a half of questions every week. But, to each their own, of course. You also get access to my debate notes if you become a member on YouTube. There's that too. But we currently don't have any. So instead what I'm going to do is I'm going to show you my website that I spent a lot of time on, because I'm very proud of it. It actually wasn't even that much time, to be honest. It was like 2 days. Here's the website. That's me. So if you haven't seen this yet, make sure to go to the website. It has a whole bunch of details about me. It has some, hey, that's me again. It has, some interesting facts. Obviously this is for people with, this can also be for people who want to reach out and like do a sponsorship or whatever. But you can see my research. There's a list of all my papers. And there's links to all of them for free. Now, these might not be the journal prepared versions. These are typically earlier versions, but these are all of my papers. Or you can also click on my Google Scholar link if you want. Merch, it says coming soon. It's on the to-do list. No exact details about when it'll come yet, but we'll get there. Anyway, so, I could just tell you about my research. So, that's my CV as well, which, you can look at that if you're interested. Do you tend to put any part of your website behind a paywall? No. So I have I have a qualm, if you will, with locking any content, like any actual educational content behind a paywall. Now this technically is considered a paywall, but the way I see it is that everybody can watch it, even if you can't ask questions. And so, that's fine. Like, I don't have an issue restricting who can ask questions as long as everybody can see the questions getting asked and see the answers. So no, nothing's going to go behind the paywall. Like, no, there's going to be no hidden content. Did I create the website myself or commissioned it? I created it myself, but I used Claude. So like Claude created it. I just told it what to do. It's actually inspired by the website of Dakota Tyler, who is a friend of mine. This website. He's really good. He's a fairly well-known science communicator. He's an astrophysicist. So like you can see that there's like this this marquee, hence the marquee up here. From Reverant, if we can measure which reference frame or velocity is closer to c, then we can then can we not say that there's a reference frame that's the furthest point from c that we can call absolute still? You can't measure which reference frame or velocity is closer to c. You can say that this reference frame is closer to c relative to that reference frame, but that's a relative statement. Did you know the moon's indigenous people are Americans? I don't think the moon has indigenous people, which is a little bit on the, I don't think that that's too controversial, right? Like, nobody lives on the moon. Oh, sorry. God, I am very hungry. Maybe we'll only do this for half an hour or for an hour or something like that. Americans were the first ones there. That nobody lives there. Just because you're the first people to Antarctica doesn't, like, the first people to Antarctica were probably like, I don't know, the Norwegians or something, but that doesn't make them indigenous. It's not how that works. Indigeneity is a lot more complicated than just who was there first. Y'all are silly. Y'all are silly. But yeah, I do appreciate you guys liking the website. The website has been, TikTok is $10 per month now? What? I need to change that. That is not my setting. I did not do that. Let's see if I can change that now. Oh god, that's a loud sound. Okay, let's go to... see if we can change this. Because it should not be $10 per month. I believe when I first set it up, it was like $5 per month or something. I don't know how to adjust this. I think I actually have to go into my live settings and do it there. Maybe I can do it. Anyway, when we live there, will we be indigenous? Because I need my university discount. Well, A, that's not how that works. But B, the point is that when you, like, there's a whole indigeneity, like, criterion, right? You have to be, like, affiliated with the land, and, like, there's a whole thing. So, and you're not going to get a discount. Discount just because you live on the moon. Kelly, thank you for becoming a... thank you for being a member for 3 months. I appreciate you. And I believe somebody just became a member. No, I don't have that there. But let's bring up Rob Kavod. Rob Kavod, how's it going?
It's going well. How are you doing?
I'm doing okay. What questions you got for me?
A couple questions. First is about sort of singularity and why, you hear all the time, like, oh, if you don't know what happened before singularity, then, people will fill in the gap that exists there. But
Sure.
what do you think is like maybe the best guess about what is happening there, and why is it that the math breaks down and that we just have no idea what's going on?
So historically, so the Big Bang is not the first time that physicists have run into the math breaking down in some sort of physical theory, right? Back in the 1800s, we had, or even earlier, really, with Coulomb's law, if you take 2 point charges and you bring them arbitrarily close, the potential energy goes off to infinity, and the force diverges and becomes an infinite, and you get a singularity there too. The way that this was resolved is that we recognized that, oh, well, classical Coulomb's law, classical electromagnetism, is not the full story. We need to promote it to quantum electrodynamics. And now there's no singularities present there at all. So the fact that we have math that says that if you keep winding the clock back, think of this as keep pushing those charges together, you get something that becomes divergent, that goes off to infinity, that you get a singularity. All that suggests is that somehow you should probably stop using classical relativity before that singularity shows up. So the way that we should understand what the Big Bang is really saying these days is that 13.8 billion years ago, the universe was very hot and very dense. And all of the models that we have for what was going on at that before that point break down, so we can't say anything definitive about before that hot dense state. This is not to say that there isn't anything before that hot dense state. This is not to say that that we can't do science about what was before that hot dense state, or that it's even in principle unknowable. It's just that we just don't have the science to describe it yet. Now, as far as my contention goes, I suspect that there was stuff before it. I don't think that it was genuinely a beginning of space and time. And that seems to be the consensus of most cosmologists. But again, this is more of a kind of like an intuition for, once you develop this kind of cosmological intuition, it's kind of the intuition that most people come to.
So I guess the follow-up question, thank you, first of all. Can there be anything outside of that hot dense state while it's in a hot dense state?
It depends on your preferred model. So if you take like an eternal inflation model, then yeah, like our hot dense state is but one of, perhaps infinitely many that perhaps coexist or are occurring at different times in different places. And so we just have like one hot dense state here, and that's going to pop and produce a universe. But like then there's like basically empty space that's rapidly expanding outside of that. That's one model. In other kind of non-cosmological multiverse models, there is nothing outside of it. The universe is everything.
Thank you. One last question. What do you think? So I had this, actually, it's kind of a two-part question. I developed this way to sort of show how the Earth is round using a pop can. I pushed in a little dent on the pop can, and I made the dent face away from me so that it looked like the pop can was just any normal pop can. You know what I'm saying? And then as I
Yep.
rotate it towards me, the peak, the mountain begins to rise up out of the
Oh, yeah, that's
the
cute.
pop can. So it was really effective. I guess like my biggest concern is that there is a lack of critical thought, and things that I thought were just normal things to learn in middle school and high school, people just don't ever seem to learn. And so, what do you think? A is the best way to teach sort of some of these basic things, and what do you think the world really should know just from a baseline perspective on our existence? Maybe, I don't know.
So I don't know what the best way to teach these things is. I leave that up to the the people who specialize in like teaching children. I do know that the No Child Left Behind Act, at least in the United States, failed miserably because it just pushed kids through to pass, even if they should have been held back. And so you end up with a lot of people who don't even understand middle school level science, which is a problem. So I don't know how else to solve that problem though, but it is what it is. As far as what people should know the science that they learn up to and including high school. Like you should know about plate tectonics. You learn that in high or in middle school science. People should know about, gravity. You learn that in high school physics, right? People should know that stuff. You don't need to know about quantum field theory. You don't need to know about general relativity or any of that stuff. But you should know like Newton's laws. You should know like what a mitochondria does. You should know about, how to balance a chemical equation. These are, in my view, bare minimums.
Perfect. Can I ask one more question?
Sure, one more, but make it quick.
Last one. Yep. Why do you think people are so resistant to scientific thought in favor of sort of religiosity and lacking critical thought?
Because science is hard, turns out.
Thanks.
Of course, take care. All right, I'm going to answer some more questions in the chat, and then I'll bring up another guest. Do creators get any of that increase from TikTok? I have no idea. I don't have a lot of super fans on TikTok to begin with. So now people will have a motivation to become super fans so that they can send their requests on Wednesdays, or send their questions on Wednesdays. I wonder if that hot dense state had a kind of Hawking radiation. Probably not. And if it did, it would have been irrelevant, right? Because it was really, really hot, so there's regular radiation. You don't need Hawking radiation. My wife teaches IB Bio, and more often than they should, they come into the class not knowing how to use basic measurement tools. Yeah, I mean, this is a failure that happens way earlier than high school, right? Way, way earlier. Our chemistry teacher in high school made us memorize the periodic table. I still know all the Latin and one Germanic. I didn't memorize the entirety of the periodic table, but I did memorize like the first few rows. Just by a mnemonic. The mnemonic is Hehi Libibi Knofni Namagel Sipskalar. That gets you to the third row. And then the fourth one is a little bit longer and harder to say. But it's not so much a mnemonic as it is just a fun phrase that is just a pronunciation of the periodic table in order. So that's that. Yeah, but it's good to see you, Hadamo. I appreciate you being here. All right, let's bring up another guest. Oh, we have a super chat. We'll read that really quick. From Keegan with the $20. Hi, Dr. Blitz. Can you give me a shout out to my wife, Summer? Because she's awesome. Summer. Can you give a shout out to my wife, Summer? You're awesome. And apparently Keegan, who I imagine loves you, is also pretty cool. Perhaps not as cool as you are, Summer. But Keegan, thank you so much. And Summer, thank you for approving the spending that Keegan is doing. Much appreciated. All right. I wish I could see who is a super fan to come up on YouTube. Have you heard about the upgrades they're doing to the Hadron Collider, and what do you think it will help identify? I think they're just increasing the luminosity, right? Which just means, so it won't, I don't think it'll help identify anything. What it means is that they'll get a lot better data, a lot cleaner data. All right, let's bring up Saturn. Saturn?
Okay. Hello?
Hey, how's it going? What questions you got for me?
Hi. So, I'm a student at a school college, I mean. Well, and my textbook in Gen Chem 2, it's a little wacky. Maybe it's because I'm much more fond of, Newton's physics stuff. Chemistry just kind of breaks my brain. But it said that super heavy elements, like the stuff above 112, 118, those wacky numbers, it's practically impossible. How impossible are they, though?
Well,
in your opinion?
Element 118 was made fairly recently, and by that I think I mean in the last 20 years. Yeah, so I guess it was discovered between 2002 and 2005, so last 30 years, let's say, or 25 years. So it's not impossible. Your textbook must just be old, because we did make element 118. It is really, really hard, though, because as the elements get heavier, they decay in less and less time. And it's also harder to make heavy elements, because essentially what you need to do to make these heavy elements is you take two lighter elements and you shoot them together in just the right way that they don't break each other, but they also are able to overcome the electrostatic repulsion. So they basically like slam together and then just stop. And so you have to you can imagine, what would be a good way to describe this? This would be like throwing a baseball into like a big block of jelly at exactly the right speed so that it stops just before exiting the block of jelly. Right? Like you have to get it just perfect, and most of the time, most of the atoms are not going to be the right speed, you're moving at the right angle. And so most of the time they'll just like blow each other up. So this is just really, really rare. I think element 118 was discovered from 6 atoms. So it just gets harder and harder as the elements get heavier and heavier, but not impossible.
Okay. Yeah. Well, I was just asking because I have a friend who actually is like a scientist who does all this kind of like wacky chemistry stuff, and he says he's seen stuff that like they're working on like element 200 or whatever, and I'm like, dude, that's like not in my textbooks, man. I don't know what you're talking about.
Yeah. So there's this thing called the island of stability. Have you heard of it?
Yeah.
So maybe that's what your friend is talking about. I mean, the thing with making heavy elements is that you basically need ways to accelerate the heavy elements towards each other in particle accelerators. And the heavier they get, the less they want to stick together, and the harder it is to accelerate them. So I'd be, if this is what your friend works on as a scientist, I believe him. I'm just a little bit skeptical. Certainly not going to be in your textbook, though, because that's like cutting edge stuff.
Yeah, well, he's technically a biologist by trade, but he worked for the military for a while on some stuff he won't tell me about. So.
Oh, okay. One of those, I see.
Yeah.
All right, well, Satorn, thank you for being here. Have a good one, okay?
Cool. Yeah.
Take care. All right, let's answer some more questions from chat, and then we'll bring up another guest. Blitz can read the room and knows who's in charge. Exactly. I know who's in charge. I mean, like, marriages should be partnerships, right? When I grow up, I want to be a mod in this chat. This is where all the smart people hang out. Well, or you can just be a member, which you are, so that's appreciated. Most of my scientific arguments against theism have come from Dr. Blitz. Well, I would hope so. That's most of the arguments that I use. I mean, not all of the arguments, but that's a lot of them. All right, let's bring up another guest. This one's Spooky. Answer some questions. Spooky, how's it going?
Yeah, it's going good. Do you know about quantum physics?
I do. What questions you got for me?
So, how does it work? Because in a normal computer, there is only 1 and zeros. And how is it more? I want to know.
So, quantum computing is, it's not all of quantum physics, but quantum computing is, it sounds like what you're talking about.
Yeah.
So, the way to think about this, and it's fairly complicated, but imagine that on one axis you have 0, and on the horizontal axis, and on the vertical axis you have 1. Now you can imagine that a regular computer can only be either along one axis or the other, but a quantum computer can in some sense be anywhere between those two axes, and in fact anywhere around the axes, and it can even have complex values and so on. It can kind of take on in-between values that is a combination of zeros and ones. And once it can do that, then you can start doing things like interference. You can start doing things like entanglement, which basically broadens the kinds of computational tasks that you can ask a computer to do.
Okay. Another question.
Sure.
This will be the last one. What is the weirdest study you found out about?
Sorry, one more time.
Like a study, or
Oh, what's the
like
weirdest study? Okay.
yes.
Oh, I don't know. It's hard to say. I only ever read the ones that are weird. I don't read the boring ones, right? But probably one that I read that fairly recently that was quite weird and very interesting is this paper, and I have it pulled up because I want to think about it a little bit more deeply.
It's about to break.
Let me pull it up really quick. Here we go. So here's the paper. It is called the Emergent Big Bang Scenario. It's freely available. You can pull it up if you want. And sorry, let me just move this over here. And what's weird about it is that they take a universe that is purely spatial. There's no time anywhere. And then they show a way that you can actually make all of the particles in that universe behave as if there's time. And they do this, there's another diagram here. They do this by basically invoking something called a clock field, which is a neat idea. And I would just suggest that if people are interested, they take a look at this paper. Essentially, this is a diagram of it's a two-dimensional depiction of what a universe could look like, where all of the blue stuff is just purely spatial. There's nothing happening. But in all of the white and yellowish areas, that's where universes exist. And they have a time-like existence there, which is just really, really interesting and really, really weird. So that's at least the weirdest recent one that I've seen.
Oh, okay. So thank you and greetings from Poland. I know what time it is for you, but for now, for us, it's 8
It's quite
PM.
late. It's like 8 o'clock, right?
Yeah, it's 8 o'clock for us, right?
Yeah. All right. Well, have a good night, man.
Same.
Take care. I don't remember how to say goodbye in Polish. Maybe they just say ciao. I think they do just say ciao a lot. Let's read some more questions and then we'll bring up another guest. So from 13un says Happy Khmer New Year to you and Annie. My wife's name isn't Annie, but my wife is Khmer. So Happy Khmer New Year to you too. From Kelly saying a vector value. Yeah, so you can think of quantum computing, or you can think of quantum bits really, as being two-dimensional vectors, two-dimensional complex vectors. And you can represent more and more complicated quantum states with more and more quantum bits as 2 to the n dimensional complex vectors. My wife's name is not public, but I do appreciate it regardless. Do widzenia in Polish, or dowidzenia, dowidzenia. That's how it's pronounced. Sorry, the DZ is Genia, is J. How is Italian? Yeah. So my understanding, and like I lived in the Czech Republic, and a lot of people say ciao there too, just because it kind of. I know ciao is Italian, but a lot of people say that colloquially. At least they do in the Czech Republic. Wouldn't your wife's name just be Dr. Blitz? She did not take my last name. Most Poles say Czesk for goodbye. Really? Okay. Well, now I know. Well, thank you, Mindforgematical, for the $2 and for that helpful information. All right, let's bring up Harit. Harit, how's it going?
Hello, Dr. Blitz. I have 2 questions for you.
Yeah, sure. What's up?
Can you hear me?
Yeah, I can hear you just fine.
Okay. So the first question is about the quadrupole, octuple, and dipole. What does that tell us about our about the Earth or solar system?
What, like the quadrupole, octupole, and dipole of what?
So basically, I think you guys call it the axis of evil.
Oh, those guys. Yeah. You mean you mean those particular moments for the CMB background.
The CMB, exactly.
You're talking about that. They don't really tell us anything.
You know the hot and cold spot, the alignment it's very weird alignment, and they said
Yep,
that
I'm
we're
familiar.
right.
I'm familiar with the axis of evil.
Okay, yeah. So what does that tell us? Because somebody brought it up.
It doesn't really tell us much. Like we don't really have a good any good model that is a good explanation that well explains that data.
Okay. So my second question is about geocentrism. Is that really consistent with general relativity?
Yeah, I mean, you can just pick whatever reference frame you want. General relativity is reference frame agnostic. So any reference frame is fine. It's just the dynamics in that reference frame might be far more complicated than you'd like them to be.
Okay. So basically, if you redo the math and then it will work.
Yeah, it's just you pick a reference frame, and then the relevant forces will kind of show up in your dynamical equations, and those equations can be either simple or complicated depending on what your reference frame is.
Okay. All right. Thank you so much.
Of course. Thanks for being here. Technically on Discord, she signed her updates on your health as Mrs. Dr. Blitz. Yeah, that's what she goes by online. Yeah, but she didn't take my last name. So, which is okay. It's kind of a weird thing to do anyway. The only reason why it's nice for that to happen is because it gives consistency for kids' last names, and hyphenating is just annoying. Not to say that it's wrong to hyphenate, but it just leads to very long last names. And it leads to, complications when filling out paperwork and things like that. It is, yeah, so different European countries do pronounce words the same in different ways than English speakers do. But I lived in the Czech Republic for a long time, and I also have visited Poland several times, and I have a good friend who's Polish. So I can pronounce Polish words. I'll butcher them, but I can pronounce them even given the Latin pronunciation, or the Latin spelling, or the standard spelling anyway. From Hanamal, I have a question. Are smaller particles' time dilation affected by added heat, increased movement? I mean, in principle, yeah. If you had like a gas made of muons, and those muons, like if you had a gas made of muons, that the temperature of that gas will affect how long the muons live, definitely. I would change my last name to Blitz in a heartbeat, not for love, just because it's an awesome surname. Well, that's fair. There's reasons why she didn't. I mean, we agree that it's a cool last name, but there's reasons why she didn't, and that's fair. Nobody's gonna make her. All right, let's bring up another guest to ask some questions from Golden Boy. Golden Boy, how's it going?
Hey man, what's up?
Not a whole lot. Got some questions for me?
Yeah, I mean it might be different for you. Do you ever talk about UAP?
Not really. It's not a particularly interesting subject to me.
Okay. I do have. I guess I want to ask your opinion on it. So if they were producing lift electromagnetically off, basically making a bubble around their craft using an electromagnetic field, is it possible to generate lift that way?
It's not even the way you described it doesn't even sound like a thing that can happen electromagnetically. Like I don't know what it would mean for there to be an electromagnetic bubble.
Right, I guess.
Like electromagnetic fields are not force. They're not like force. You can't make force fields with them, really.
Right. I'm trying to think of a better way to phrase it. I'm gonna come back later, bro. I'm gonna come back later.
Enough. You're good. Take care. All right, let's bring up Heath. Would you agree that the parsec measurement is useless? No, I love it. Heath, what you got for me?
Hey, Dr. Blitz, how are you?
Doing all right.
So I had a question that's I've wondered about for a while. Brian Cox was explaining one time a concept on a podcast where, and this is, I think, just like classical physics or, Einstein type physics, but where the proton, when it's traveling at great distances, that due to the special relativity, that it only seems like a matter of minutes, maybe, if they were to travel to the Andromeda galaxy. I think that's the example he uses. And I was just wondering if there's a way you can explain like a simpler version of why I guess, the time dilation, like why it shrinks that distance and doesn't travel the light year distance, if that makes any sense. I'm not sure I worded that well.
Yeah, so I'll do my best. So what's happening here is, the closer you're moving to the speed of light, there are kind of two relevant effects. There's time dilation and there's length contraction. So if you are moving, let's say that you leave the Earth going 99% the speed of light or whatever it might be. From your perspective, all of the distances or all of the distances that you measure in the direction of travel are going to be compressed. And the reason for that is essentially, and this is the ultimate reason for why anything weird happens in relativity, is because the speed of light is the same for you as it is for everybody. It's always, you will always measure light moving at the same speed. And so at least from that fact, you can infer that lengths have to be compressed. It's a little bit complicated, it involves a thought experiment, but from that fact, you can infer that. Now, similarly, from the perspective of somebody on Earth, they will see your clocks move slowly, and you will see their clocks move slowly. And so what this is getting at is that something like duration or something like distance, these are just not properties of the universe in an objective sense. Thank you, Chase. That's a good way to describe it. What is meaning they're not invariant, meaning that, depending on how you're moving or where you are or, what's around you, how you measure distances or how you measure times, that can change. What is true is that there's something called a space-time interval, which is sort of like a combination of a distance and a duration. That thing is invariant. And all that says for you anyway, is that your clock will always move at 1 second per second, which is not a useful thing to say, right? It's like obviously true. So this phenomenon that you're describing is merely a consequence of this fact that what we think of as objective quantities like distances and durations just aren't. Now there's a whole bunch of math that could be used to make this prediction. There's a thought experiment that you could come up with involving trains and lightning and things like that, that could perhaps illuminate why this is the case. But there's not really a simple explanation as to why this happens.
Does the universe, is it fair to ask, is this even a fair question, does the universe do any type of accommodation due to the speed of light being like this finite thing?
I don't know what you mean by accommodation.
So like with this, I think when you were talking about time dilation and I guess the distance contracting, is that I guess a fair question? Is this distance contracting, is that where, like, I don't know, I guess think of the universe as like almost accommodating this finite speed of light?
Yeah, you could think of it that way. So the distances contract and the times dilate in exactly the way required so that everybody always measures the speed of light as the same value. That is certainly the case. Okay.
Well, that is all I had. I appreciate it. Thank you so much.
Of course. Thanks for being here, Heath.
Thank you.
Yeah, so Hadamal asked, would you agree that the parsec is the parsec measurement is useless? No, I don't think so. It's old, but I don't know if it's useless. What were the criteria to join and ask? It is members only or super fans only on YouTube or on TikTok. I don't have a way for you to join through YouTube right now that can filter out people who are not members on YouTube. So currently there's no way for YouTube members to join. I need to figure out how to do that, and I haven't done it yet. Yeah, let's bring up another guest. From It's Marco. It's Marco, how's it going?
Good, how are you?
I'm doing okay. Marco, what questions you got for me?
I don't know if you remember a while ago with the Maharana 1 CPU that like Microsoft had made.
Yep.
I remember them saying they created a new state of matter and they used like time crystals.
The thing that they created allegedly were called topological qubits.
Yeah, I guess I was curious if you could kind of explain what those were.
Yeah, so first of all, they didn't make them. It was fake news, unfortunately. But so okay, I don't know a lot about topological qubits. What I do know is that there is a phenomenon called braiding, which just think of in terms of strings, right? If you take two pieces of string that are both running up, and then you wrap one piece of string around the other and then keep it running up so that one is kind of wrapped around the other, you can't really separate them from each other. You can't really break that braiding without like undoing it and going through a whole bunch of processes. So this would be called like a, you might call it like a topological linkage of some kind. And so what a topological qubit is claiming to be, and what they claim to have made, which they didn't, is and when I say topological, it's because there's some sort of like shape that can't just be like smoothly undone. You have to like do a discrete action of like unwrapping the whole thing, right? So the claim that's being made here is that they created a kind of qubit, qubit being like a quantum bit. It's the smallest unit of quantum computing.
I'm kind of familiar with that.
So what a topological qubit is supposed to be is there's supposed to be like supposed to be a discrete phase of matter that in some sense stabilizes the quantum configuration in the same way that like the wrapping of the string around the other string is stable. You can't like just wiggle it and it'll go away. So if this thing had actually existed, it would have been a huge breakthrough, because one of the biggest issues with quantum computing is maintaining quantum coherence. But if you can kind of stabilize the qubit so that it can't just kind of decay away, that would be enormous, because then you could, keep coherence much longer and so on and so forth. I don't know the actual details of the construction that they used, or that they claim to have used, but it's all really complicated condensed matter stuff. But that's the rough idea.
Interesting. Yeah, that was really about it. I remember that from like a few years ago and like trying to understand it, but
I think it was it was February of 2024 when they made this announcement.
Yeah, it was about 2 years or so. But
and the only reason I know that is because that's when I was in New Zealand, and I remember them announcing it while I was in New Zealand. So,
well, yeah, that was really about it.
All right,
I appreciate it.
Well, thanks for being here, Marco.
Thank you.
Just join the Discord. Yeah, so the Discord doesn't. I don't have a way to do that. You can make a Discord voice chat channel that only people with the YouTube member role can access. That's the only way. Yeah, I could do that. That might work. Yeah, I should try that. What does condensed matter mean? This is a good question. Condensed matter it's just a branch of physics. It used to be called solid state physics. But basically it's just like the physics of like stuff, matter that is in a condensed state, like solids, liquids, metamaterials, quantum computing. It's that kind of, it's like the physics that's involved with like, it's very materials physics kind of physics, or material science kind of physics, where you're like thinking about building certain kind of insulators or superconductors or topological whatevers, and it's all that kind of stuff, which is it's a whole very broad branch of physics that I know very little about. I heard that the viscosity of fluids increases when nearing relativistic speeds. Doesn't that imply that there is physical phenomenon that happens when approaching these speeds? So I've never heard that claim. However, what you can say is that you can say that there are different equations that would describe. So what I know from cosmology, and what I know from, what I know, is that there are different equations that describe, say, relativistic fluids versus non-relativistic fluids. And when we say that, what we mean is we're talking about like the how the momentum is related to the velocity, or rather how the momentum is related to the energy. So if you have one relationship between momentum and energy, that will be different than if you have another relationship between momentum and energy. So from the perspective of the fluid, it's not relativistic, but everything else will be. So the things that you're interacting with will behave in a certain way. And from the perspective of somebody else, who's sitting still and the fluid is rushing by, say, at a relativistic speed, the accurate way to describe that would be with the relativistic equations. So these kinds of things actually tend to balance each other out. So you still don't get a preferred reference frame to determine which things are actually relativistic and which ones aren't. All right, let's bring up Lloydie. Lloydie. That's a good name. Lloydie, how's it going?
Hey man, how are you?
I'm doing all right. What questions you got for me?
Just a couple, right? First, yesterday I sent you a message about Gödel's incompleteness theorem and you were
Sure.
like, you mean the ontological one, and I got mixed up. I meant the ontological one
Sure.
that is supposed to prove God. I just wanted your view on that, and also I just wanted to ask what your kind of favorable solution to the Fermi paradox is.
Yeah, so as far as Gödel's ontological argument, I have contentions with several of the axioms. I just don't think that they're true. It's like axiom, like if you go on Wikipedia, there's like a description of what each axiom is. And let me just pull it up so I don't get the numbers wrong. I have an issue with axiom 3, and I have an issue with axiom 5. I mean, the other axioms are probably fine. But yeah, so I just don't think that those axioms are true. And if you don't think that those axioms are true, then you can't prove, then the theorem doesn't hold, right? Regarding the Fermi paradox, I just think the universe is really big, and it's actually hard to travel through space. I don't think that FTL travel is really possible, so you're going to have a hard time seeing anybody, or being or visiting anybody.
Yeah, that's my view as well. And just lastly, do you think the cycle of the universe goes big crunch, big bang?
I'm pretty agnostic about it. I don't have a particularly strong position one way or the other.
Okay. Well, thank you so much.
Of course. Thanks for being here.
No worries.
Oh, sorry, I cut you off a little bit early there. Let's bring up another guest. Oh, never mind. There's some questions, then we'll bring up another guest. By the way, if you guys do want to ask questions, you know how to do it. Become a member. It's like $4 or $5 a month. We're going to do these once a week. So here's some extra value that you'll get if you become a member or a super fan or whatever it is on TikTok. Very speculative question. Photons have no mass and move at c. Is there any relation with relativistic effects with any other quantum fields other than the Higgs? There, rest of the question. I don't know if there's a rest of the question. Is there any relation with relativistic effects with any other quantum fields other than the Higgs? Oh, well, gluons also travel at the speed of light. If that answers your question. Dr. Blitz, do you think humans are ever going to be capable of leaving our solar system? Well, yeah. Like, we're in principle capable. It's just really slow and probably not worth it. All right, let's talk to someone. Someone, how's it going?
Oh, hello, hi.
Howdy. What questions you got for me?
Good, thank you. You were talking about speed of light earlier.
Mm-hmm.
Is there something special about speed of light that is independent of a space-time that makes it move at that speed?
Well, it's more that light moves at the maximum speed because it's massless. And the maximum speed is just whatever it is in our universe. And so light is going to travel at that speed. But so will gravitational waves, so will gluons. Anything that doesn't have mass will move at that maximum speed.
So that's a constant that we don't know about. It is just a constant. It is how it is, and we don't know anything else. Why it breaks?
In some sense, it's not a question that really makes sense to ask, because the constant has units. So, like, sure, it's 300,000 meters or 300,000 kilometers per second.
Or a
but
ratio.
it's also one Planck distance per Planck time, right? So, like, the number is not meaningful. The only thing that's meaningful is that there is a limit, that there is a maximum speed. And then whatever units are, you can make the number be whatever you want it to be. And so what's special about our universe that we don't have an explanation for is, why does our universe have a maximum speed rather than not having a maximum speed? And that's a question that people think about, but its actual value is not particularly physically meaningful.
Right, I understand. So it's the ratio that's why that ratio is such a ratio.
Why there's a ratio, why the ratio isn't infinity. Let's put it that way.
Okay, so does that mean that tachyons are not possible at all?
There's not really any theoretical models that are A, well motivated, and B, well supported by the data, that imply tachyons can exist.
And anything with a mass would not be at the speed of light.
Right.
For example, neutrinos would
Even
never.
neutrinos also don't move at the speed of light.
And do neutrinos, if you shoot a neutrino through the Earth, when it comes out the other side, would you be able to see any difference to that neutrino when you detect it as to what material it went through, for example, if it had any interaction at all or not?
Maybe. So in principle, one could like measure that it has lost energy. But we do not have the tech to do that.
So the wave would come with a lower energy level.
It'd be slower, yeah.
It'd be slower in speed.
Yeah.
And if so the peaks of the wave would come slower.
Well, a neutrino is like a particle, right? Like it's just like it's not like a continuous wave. It's just a particle. So it would just take longer for it to get from point A to point B.
I see. So multiple neutrinos. And in case of photons, when we say they are quantized and they are packets, when, for example, they hit our eye, they say the frequencies would it get observed? The full so I'm all over the place. When we do the double slit experiment, we see that a photon moves. So it moves like a wave. So it moves in different places. Now, if the eye is smaller than that wave, does the eye still absorb the whole packet or no part of it?
If you interact with the photon, yes, it absorbs the whole thing.
So interaction means no one else will be able to see that. So what happens to the wave? It compresses itself, comes into one location and gets absorbed by the eye?
Depending on your preferred interpretation of quantum mechanics, the standard Copenhagen interpretation is just the wave function collapses during the interaction, and it collapses in the location of where the detector is.
So by collapsing, it means that we know the location of it. Otherwise, it was at multiple locations before that.
Yep.
So that's basically totally out of a standard model, or
no, that's just normal standard quantum mechanics.
And the the neutrinos, there are three types. What's the difference between them?
They just interact with the leptons in different ways, or the other leptons. So electron neutrinos interact easily and kind of directly with electrons. Muon neutrinos interact directly with muons, and tau neutrinos interact directly with tau particles.
And they pass through material the same way in terms of their interactions, or?
As far as we can tell, yeah. Or in very, very similar ways anyway. There are actually the different flavors of neutrino, which is, electron, muon, and tau. These different flavors are not the same as the particles that have different masses. So when a neutrino is just streaming through space with a certain amount of mass, it's not one of those three flavors, it's some combination of those three flavors.
And why do we call it electron?
Because you mean the electron neutrino?
Yes.
Because it interacts directly with electrons.
Oh, I see. And if it passes through one type of material, for example, through a rock versus a plastic, if you have a detector, can you tell anything what that material was or not?
Probably. Not with current tech. Certainly not with current tech. No.
Because there's no interaction probably other than.
Well, we don't really have a good way to measure, like with an extreme degree of precision, how energetic the neutrinos are to like be able to distinguish between. Well, maybe we can. I guess we can measure neutrino energy levels. So, yeah, it's kind of the same way with gamma rays, right? If you take a gamma ray, it's like it can certainly lose energy. Well, gamma rays can't. They'll either be absorbed or they'll be blocked, but or they will pass through. But like you can't really tell if a gamma ray is passing through, 10 meters of water or 1 meter of steel.
Okay, but there is no such thing like there is redshift to photons. There wouldn't be anything like that to neutrinos.
Everything redshifts.
Everything redshifts, even
Yeah.
neutrinos.
Yep, even neutrinos.
But
So
at
there
a
would in
small
fact be a
distance-
cosmic neutrino background, and it would just be composed of very, very low energy neutrinos.
Oh, okay, but that's not something that you can detect locally because for such short distances there is.
Yep.
So when the neutrino, everything you say, what else does shift other than? I mean,
Everything
everything is
redshifts.
EM anyways. So
If you take anything, if you shoot it through expanding space for long enough, it will redshift.
even a spaceship.
Even a spaceship, it'll slow down. Yeah, it will lose momentum.
Oh, it will lose momentum, but it wouldn't stretch.
Redshift just means a decrease in momentum. Now, it turns out that the way that a photon's momentum decreases is by stretching. But yeah, so when I say redshift, I just mean that it loses momentum.
So a photon, like the wave itself, the peaks and the valleys, they do not stretch. It's slowing down.
No, it's not slowing down. It's losing momentum. And the way that a photon loses momentum is by having the wavelength stretch out.
Okay, but there is a spin that the photon has.
Photons do have spin, yeah.
They do have a spin.
Mm-hmm.
So their spin slows down, or something.
No, it's the spin of a photon is not related to speed.
Not related to momentum.
No, it's not related to its momentum. No, the spin of a photon is either plus or minus one, or it has a magnitude of 1. It's a vector boson, so it just has a certain amount of spin, and it's not related to its momentum. No. But look, there are a few other people in the queue that I want to answer their questions to, so I'm gonna let you go.
Thank you.
Thank you for being here and asking questions. I appreciate you. Take care. All right, some questions from the chat. Will you still take us to Prague if you get 300 superfans? No, I don't live there anymore. What is your take on the problem with a charged particle affected by a gravitational field? Does it radiate or not? I made a video on this. I take whatever is the opposite position of Feynman. From I want to make sure that I don't miss any questions. Okay, let's bring up Golden Boy. Golden Boy's back. Welcome back, Golden Boy.
Hey, bro. Sorry about before.
Yeah, you're fine.
Can you hear me well, though?
Yeah, I can hear you just fine.
Okay, yeah, I'm just outside, so I was just making sure. Okay, so from your standpoint, right? Let's say, I mean, take the if UAP exists, if they don't, out of it, right?
Mm-hmm.
From a physics standpoint, if it was not making noise, if it hovered off the ground, if it created almost invisible lift that we can't explain, what would your theory be on that? Do you think it is electromagnetism, or do you think it's something that we just haven't, like a new study, like a new field we haven't found yet? And is electromagnetic amplification possible on a scale like that? Like if you were to put stabilizers.
So I don't think that it would be electromagnetic, because
you don't think so? Okay.
It would like if the electromagnetic if you have a spacecraft that weighs, I don't know, however many thousand pounds or whatever, and you're somehow hovering. Well, the only way that electromagnetism could cause that is if you're like, it is true that the Earth is charged a little bit, and the upper atmosphere is also charged.
Right.
And so the only way that you could hover is like, induce a negative charge on your spacecraft or whatever to repel yourself from the negatively charged Earth.
Sorry. Could you knock down mass theoretically, not to zero, because everyone knows
there's no known way to do that. That's not consistent with any understanding of physics that we have. But so it can't be electromagnetic, because if it were, the amount of negative charge you would need to accumulate would be like, you'd be like ionizing the air, and you would be like causing explosions.
Way too much fucking energy use.
So it would be like, it would not be quiet. It would not be unnoticeable, right? And so So it can't be that.
Is
Could it
there
be, like-
anything like that that we even know about? Is there anything like
No,
that?
not really. I mean, could it be? I guess it could be like some like a
Electrohydraulic system, water,
I'm thinking that it could be like some superconductor, maybe, because you can get superconducting levitation, but that requires a really strong magnetic field in order to happen. And
so there would already have to be a naturally imposed
Yeah.
field for amplification to even work.
well,
So the
it's not
craft
even amplification.
itself.
It's like
Okay.
it's not an amplification thing that happens. All that happens is that you kind of just like move along on top of the magnetic field with the superconductor, and you need a strong magnetic field for that to happen. Like you can go look up superconductors.
Like
It's-
really
it's
fucking
not
strong.
it's not related to the strength of the superconductor or like how good of a superconductor it is. It's related to the strength of the magnetic field. And the Earth just doesn't have a very strong magnetic field. So
Do you? Yeah. What's? I mean,
like,
what is your
honestly,
take on
if
that?
I
Do you
saw
think it's
that,
possible?
if I saw that, I would be like, this is fake. It's more likely to be fake than it is to be any kind of real physics.
Right. God damn. I mean, what happens? I mean, what if there is a day? Do you think inertia is breakable? Do you think we can
Not with any
break
current
inertia?
known physics.
Right. Right. All right, brother. Well, thank you for the time. I appreciate it.
Yeah, of course. 1 sec. I have to take a. Don't mind me. I'm just drinking water. Definitely not taking an antibiotic. That's how I normally drink water. Definitely. I think we got a Cash App. Oh no, I already read that, I think. Oh, that's me. Why am I me? Why am I hearing myself? That was weird. Do you think we will ever find a more efficient way to create antimatter, and would there be a benefit? Maybe there will be some way to generate it or create antimatter more efficiently in the future. I don't know what that would look like, because antimatter is like, we understand antimatter really well. It's the same. It's just as difficult to create antimatter as it is to create matter. That's the issue. And creating matter is hard. We use particle accelerators to do this. But if we could, it would be beneficial. It'd be really efficient. If we could store it effectively, it'd be a very high density energy source. All right, let's talk to King of the Chill. King of the Chill, how's it going?
Good, how are you?
I'm doing all right. What questions you got for me?
So I just have two.
Sure.
The first is really simple. I got in an argument with a coworker, and like, I cannot be wrong. The periodic table of elements does not only apply to Earth, right? That's universal.
It is universal, yeah.
Okay, I thought so. Dude, I got in such a bad argument with him. I just told him, yeah, you're right. I didn't know that. Sorry. I guess it only applies to Earth. And then, like, one of the funniest things I ever heard, I brought up, someone dropped something, and I said, like, oh, something about gravity, and this girl was like, gravity only applies to Earth. Like, she was joking, but I was like, that was a good one, bro. All right.
It's a good meme. I'll give you that.
That shit was fire, yeah. Second one. Do you think that the double slit experiment kind of implies that consciousness may be like a fundamental part of the universe?
No, I don't think so at all.
No?
And also, most physicists don't think so either. The double slit experiment, again, if you take the mainstream view, of course there are going to be fringe views, but if you take the mainstream view, the double slit experiment doesn't involve anything with consciousness whatsoever. It has to do with a big thing interacting with a small thing. Now, the fact that we are a big thing and we are also conscious is kind of irrelevant, at least the mainstream view. You could do the same thing with a camera.
Okay. So, like, I guess just like any bigger thing interacting with a smaller particle like that would still break the interference pattern.
Yep.
Okay, interesting. I didn't know that.
Yeah, it's a common misconception, actually. At least, look, and there are going to be people who say, oh, well, you haven't proven that. You haven't proven that consciousness isn't involved. But, like, I'm just telling you what the mainstream view is.
Right. So, like, you're saying, like, if a camera were to capture that, like, us viewing the camera would be irrelevant.
Yeah,
It would
it's already in the camera's memory chip, right?
Okay, cool. That's all I wanted to know.
Okay, fair enough. Well, thanks for being here, bud.
Yep, appreciate you.
We have a super chat from Mr. Pacho, or sorry, I believe it's correctly pronounced Paco, but everybody now pronounces it Pacho. So from Mr. Pacho, your comment about ionizing air definitely makes me want a what if style series of videos where you talk about hypothetical nerd shit. I do it occasionally, but it has to somehow be grounded in some physics I can actually do. This might be an example of one though. How much negative charge do you need to distribute to the bottom of a spacecraft in order to cancel out the gravitational pull pulling you down? And it's probably not very much, but it would probably be still really, really bad. In fact, I did something similar on this. There was that one video that went super viral where somebody says, you know, what for my genie wish, I wish that every atom had one more electron, and then I described how this would destroy the universe, right? So that was fun. And from Ogar Debates with the $5, much appreciated. Are there examples in quantum physics of things coming into existence without a cause? I thought there were, but was told that's an outdated view. Sort of. It depends on what you mean by things coming into existence. So, for example, if you take a neutron, just kind of on its own, not in an atom, that neutron will stop being a neutron and will start being a proton, an electron antineutrino in a way that is in some sense uncaused. It just happens spontaneously. There's not really an explanation for why it happens when it happens. This is so we describe these things statistically because there's no way to account for the when of when it happens. Now, what you can say is that it happens because it's unstable, and perhaps that's a cause. But the explanation for why it happens is not. There really isn't one. Now, does that count as something coming into existence? That depends. There's also the question of, like, what about what's happening near a black hole? Like for Hawking radiation, you have particles basically just leaking out of a black hole. Depending on how you interpret it, you could interpret that as particles popping into existence at the event horizon of a black hole and streaming out. That is an interpretation, and you're not going to have an explanation as to why the particle pops into existence when it pops into existence. But it's also not necessarily the best explanation we have for the phenomenon itself. Another explanation would be that you have particles tunneling through from the inside to the outside, and then you need an explanation as to why they tunnel through when they tunnel through. Again, that doesn't have an explanation, but that might not be the same thing as a particle popping into existence. So it just depends on what you mean by what you mean by coming into existence, right? I read it Psycho for the longest time before I got new glasses. Well, it was apparently, I don't know if this is actually, I'm not gonna ruin it. This is Peiko's choice to tell the story if he wishes. Let's bring up Sal Kase. Sal, how's it going?
Hey, how we doing?
I'm doing okay. Sal, what questions you got for me?
So I have a friend who's obsessed with studying entropy, and whenever he explains it to me, it just flies right over my head. So I was hoping you would give me, I guess, either A, like in layman's terms, try to explain entropy, and in the scenarios in which it is, how would I say this? The way that I observe things is through contrast. So I would have to try and imagine a situation in which, like, entropy is an actual important, where it affects the situation or a context in which that would not be possible without entropy, in a sense. Am I making sense?
Yeah, sure. I mean, like, no, but I know exactly the mistake that you're making. I can hopefully help clarify. So first things first, the standard way that we kind of describe entropy is as this, in some sense, it's a measurement of how disorderly a system is. So the standard story, and this is an analogy, it's not quite exact, but the standard story is that if you have a very clean room, a very organized room, the entropy is low, and if you have a very messy room with things all over the place, the entropy is high. And roughly what the way that we can describe this quantitatively is basically how many different ways can a thing be when you zoom in without it changing how it looks when you zoom out. So a messy room Like if the room is messy, it's going to look messy whether or not, you know, your shoes are on the left or are on the left side of the room or on the right side of the room. It'll look messy regardless. And so in that sense, it's going to have, there are a lot of different ways that the messy room could be while still looking messy. But there's perhaps only a few different ways that the room could be while still looking organized, right? If you have even one thing out of place, it will look less organized, that you will notice it. You will notice that there's a difference. So entropy, we say you have low entropy. Yeah, sure, go ahead.
I'm sorry. So if we're using entropy to describe it as systems in general, does that mean that it shares a similar, I would say, a similar playstyle or effect, things like average, mean? Like, is it just the statistics of measurement in terms of systems, or does it actually have like a, I would say like an energy component?
It's a property of a system. So in the same way that like temperature is like a thing that you can measure about a system, entropy is a similar way. It's like a thing that you can measure about a system.
Interesting. And I guess my confusion now is in what context are we considering it to be systems? Are we talking about just all energy systems, all statistical number systems, or all orders of properties, all just every single parameter possible, or are there limitations?
So typically, and I mean, people try to apply notions of entropy to very wide contexts. The safest place that you can apply the concept of entropy, that you can like reasonably calculate the entropy for such a system, would be in some system that is in what's called thermodynamic equilibrium, meaning that there's a well-defined notion of temperature for that system. There's a well-defined notion of volume for that system. There's a well-defined notion of pressure, perhaps, or there's a well-defined notion of, you know, like chemical, like the chemical species, which is like called chemical potential. So if you have a system that's in some sense in equilibrium, then you can probably talk about the entropy of that thing.
So would entropy be considered like the standard deviations in a sense? Like, let's say you have consistent constants, or
it's not a statistic. I mean, it is related to statistics, but it's not a statistical measure. It is those microscopic properties could be different without changing the macroscopic properties. It's just a measure of that. It's in some sense, it's not a ratio, it's a logarithm, but it's literally as described. So if you have, like, imagine you have a gas with a box in it. Sorry, a box of gas, right? You have a box that has gas in it. You could imagine that the atoms can be in different configuration, or that the atoms of gas molecules can be arranged in different ways, but the pressure is still the same and the temperature is still the same, even if the atoms are in different places, say. If that's the case, then the more different ways that you could rearrange the atoms to get the same pressure, temperature, volume, etc., the higher the entropy. The way to think about this is it's a number, right?
Is it like sort of and this might just be because you mentioned the box, but I'm drawing comparisons to like Schrodinger's cat in a sense. And it's like in way that using your box of gas as an example, the measurable outcomes that we would be able to quantify, things like temperature, pressure, all of those things, those are all numerical equivalents and don't have any variance. But the different ways those numbers can all be produced is what is entropy.
Entropy tells you how many different ways those numbers can be produced. But yeah, that's roughly the idea.
I'm missing the nuance of how it's different what I'm saying.
Entropy isn't a stuff, right? It's not, entropy doesn't, it's not a thing that flows.
It's not, so I get what you're saying.
Right.
It's, okay. I think I get what you're saying now. So it's not like, it's the number of different ways. All right. I'm getting this.
Good.
Thank you so much. That helped a lot.
Anything else?
Entropy, let me think. Entropy, I guess if you could explain the context in which entropy became relevant.
Yeah, sure.
Like, what were they trying to figure out?
Yeah, so historically, I don't know the details historically of like who did this or whatever, but there was this observation in the 1800s, I maybe even going back as far as the 1700s, that so you know, the 1800s was the century of the steam engine, right? Like, people were trying to figure out how to make more efficient steam engines so that their textile factories could, you know, you didn't need as big of a water mill, you know, steam engines, right? This is a thing. Mm-hmm. So they were people were trying to understand what makes steam engines, or what makes engines in general efficient, And there was this idea, what ended up kind of, you know, after decades of studying this idea kind of coalesced that there is a degree of efficiency of an engine that is somehow related to like the temperatures of the stuff that are involved in the engine. And
could you use simpler terms to explain that? I'm sorry, I'm not quite comprehending the idea of the efficiency portion.
So I mean, think of efficiency in like the normal way. Like you put in some amount of electricity, you get some amount of work out, right? Like, you know, an efficient car, it doesn't use electricity, but like an efficient car can go further on the same amount of gasoline, right?
Or are you talking about like the smallest ratio in which they could put in the smallest input to get the most output?
Yeah. So obviously you can't go more than 100% efficiency because you can't get more out than you put in. At least that's one of the laws of thermodynamics. But the question is like, how close can you get to 100%?
Yes.
And the one of the so there's a question about certain kinds of engines, and they're basically the engines that we use today. These are things that do mechanical work. They like move things, or they do something mechanical based off of some input of heat, right? So think about what happens in a car. You burn gasoline, it makes something hot, and then the heating up of that gasoline, which, you know, explodes or whatever, that causes something mechanical to happen. It causes the car to go in this case. So these are called heat engines, where they take heat as input, maybe from like burning gasoline or from a fire or whatever it might be. And then they use that to convert it to some useful work, like you do something mechanical. And so where the idea of entropy comes from, it's very, very closely related to this idea of the amount of heat you put in. You'll never be able to get 100% of that heat turned into mechanical useful energy. Some of it has to leak out. And this is because, and we're abstracting away a lot now, this is because in some sense, the entropy of whatever you're studying always has to go up, or at least stay, like it can never go down. And in fact, for an open system, it can't even stay the same. It has to go up. So in some sense, this concept of entropy came about when studying kind of how like you can't get to 100% efficiency. That's where the idea comes from. And this more statistical interpretation that I described earlier, that came about later. It came about in the late 1800s when people were trying to understand why is it that this number called entropy, which tells you like, you know, what direction a thermodynamic process can happen in, like, you know, you can burn fuel, you can burn gasoline, but you can't unburn gasoline. There's like a directionality to how these kinds of things can happen. So there's a question as to why that directionality is the way it is. And it turns out there's just a number that you can calculate. And that number, what they called entropy, and it always increases in the direction that things can happen in. And so people were trying to figure out why that's the case. Why is this number always increasing? Or like, you know, if you have like gasoline, why does the entropy of the gasoline go up when you burn it? And what they found is that what's happening is you have like just some collection of gas molecules or water molecules, whatever it is. They're always bumping up against each other, and so they're always randomly rearranging. And so what you'll find is that if there's more ways that the particles can be without changing their like kind of zoomed out properties, then it's more likely that after bumping around against each other, they'll end up in one of those higher entropy states. So that's the connection between this more ways the system can be without changing the macroscopic properties and this business of things going from low entropy to high entropy. That there's just like kind of tendency towards disorder. That's the connection that came up, and that was solidified around the year 1900. This kind of connection between the two.
I'm realizing that some of my misconceptions about entropy might be due to a misunderstanding of how what quantum mechanics is and how exactly it works.
So this doesn't actually require quantum mechanics. This was all formulated before quantum mechanics was even known about. This is, in some sense, classical. You can just think of like gas molecules bouncing off each other, right? But this is, I mean, like what you're asking is a deep question about thermodynamics and the relationship between kind of this tendency for this number called entropy to increase, which is the thermodynamic description of entropy, and this kind of statistical description of entropy, meaning how many different ways can this thing be rearranged without changing its macroscopic properties. And that's a really deep relationship. And, you know, it's the kind of thing that you learn over the course of a semester in college.
I guess the reason I bring up quantum mechanics is because at least I've heard several times you bring up this idea of randomization and how it's constantly changing. And the way that I'm thinking, and I relate that directly to quantum mechanics as this idea of constant randomization and like trying to quantify what a state is like at a certain moment. I'm sorry. I feel like I'm not drawing the correct comparison. I might be misunderstanding this.
So it doesn't have to be truly random, but if you have like, imagine that you had like a trillion, think of like the lottery, right? Like you have all these balls bouncing around inside like the thing that they're spinning. It's not like actually random, right? Because it's just balls bouncing off of each other. And if you had like a big enough computer, you could figure out where each ball is going to bounce after each collision and blah, blah, blah. But it's effectively random. And so that's what's happening with like all of these water molecules or gas molecules when they're bouncing off of each other.
Okay.
Like it may as well be random, even though, you know, it doesn't have to be actually random. The point is that they kind of rearrange themselves in a way that they will eventually reach all possible configurations. And if there's more configurations in one state than another, then you end up in the more configuration state.
And the number of configurations is directly correlated to entropy.
Yeah. So imagine that you had like imagine that you had like a million different configurations for a collection of gas molecules in a box, say. And let's say that 900,000 of them ended up having, I don't know, a pressure of 5 and a temperature of 10. And 100,000 of them had a pressure of 4 and a temperature of 8. Well, if they're just bouncing off of each other, most of the time, they'll end up in the configuration that had 900,000 ways that it could be. And so you'll just end up going to this particular state that has more possible ways it could be. And it turns out that that's how we describe entropy. It's going from perhaps the low entropy configuration with only 100,000 states to the high entropy configuration with the 900,000 states, just because there's more ways that it could be one of the 900,000.
And and that's why you said that it was logarithmic, because it's approaching a limit.
Well, it's not approaching a limit. It's just it's a logarithm for technical reasons that I don't want to go into.
Thank you. I really appreciate it. Could I ask one more question?
As long as it's quick.
That's fine. I don't think it'll be a quick question.
Fair enough.
I'll give someone else a chance. Thank you.
All right, take care. All right, let's read some questions, and then we will bring on another guest. From Chard with the $10, much appreciated, Chard. What would happen if you live streamed a trip to a location where light took 30 minutes to get to Earth? Would it progressively lag or remain unbroken, but the astronauts would be in the future? Oh, so it depends. What would happen is that in some sense, like if it wasn't live streamed, if it wasn't digital, because digital requires certain bit rates, if I was sending a radio signal back to Earth, the radio signal would get lower and lower frequency. So the same signal would come in, but the peaks and troughs between the waves would come in more and more slowly because there's a longer time between each peak and trough because the frequency would go down. If it's digital, I don't know how it would work digitally. It would depend on the encoding, I guess, but I imagine it would be a lag. All right, let's bring up another guest. Let's bring up Foofs. Foofs, how's it going? I'm doing good. What question you got for me?
So I have a question that has to do with the speed of light, and I don't know. I guess like to me, like intuitively, it sounds like it's a coherent and like a question that makes sense, but it might not. So when I ask,
if it doesn't, I'll let you know.
Okay, cool. So obviously, to my knowledge, the speed of light is a constant, meaning that it is always the same speed, no matter from what perspective. And so let's just say, like, you know, let's say you have the speed of light, and then you have like a horse that's racing it at like c minus 1 kilometer per hour. So obviously, like from the horse's perspective, given, you know, the consistency of the speed of light, of the theory of speed of light and how it's constant, the speed of light would still look like as though it is going, let's just say 300 kilometers per hour, correct?
Well, 300,000 kilometers per second, but
Yeah,
yes.
I mean per second. Sorry. And so from an outside perspective, how would that look like? Let's say someone was looking at the race.
From the
How would that look to
like
them?
they would see that the horse is only lagging behind the light beam by 1 meter per second, or however much.
Right.
They're
But
lagging
so
behind it.
it's right now, like, let's just, let's say that light is right next to me. And from my perspective, it is going at 300,000 kilometers per
Mhm.
second. That would, I mean, I guess not like fully, but I would basically remain stationary compared to it, right?
Well, from your own perspective, you're always stationary, right?
I mean, yeah, I guess, but I'm saying like relative to the speed.
Yeah.
Like you would, yeah. So from the horse's perspective, does he also look stationary compared to the speed of light?
Yep.
How does that make sense? So is the speed of light like way ahead of him? Like how it would look?
In 1 second, from the horse's perspective, the light beam will be 300,000 kilometers in front of them.
Right. And from an outside perspective, he wouldn't?
Yep.
I mean, it wouldn't be?
And that's because, from the horse's perspective, distances are warped and time is warped.
Oh,
so from the perspective
stretches.
So if you're watching this happen, from the perspective of the horse, from the perspective of you watching the horse and the light beam race each other, the horses, like, let's say the horse is wearing a watch. Horses don't wear watches, but suppose that it was. You would see that horse's watch in 1 second. It would take like, weeks for you.
Yeah,
it would take weeks for 1 second to pass on the horse's watch.
Yeah, no, I'm aware of the time dilation part of it.
And
Go ahead.
So in the amount of time that it would take for the horse's watch to go from 12 noon exactly to 12 noon and 1 second, the gap between them would have grown by 300,000 meters or 300,000 kilometers.
But that's why I think I get a little bit confused as to like, how can you relate that to a distance when you're talking about time? You're saying,
so from the perspective of an onlooker, the horse and the light beam, the gap between them is growing by, say, 1 meter per second, right?
I see, okay.
Because the horse is moving 1 meter per second slower. So it would take a certain amount of time for that gap to get big. And so from the perspective of the onlooker, it might take a few weeks for that gap to be a few thousand kilometers or something like this. Just because it's growing, but it's growing slowly.
Mm-hmm.
And in the amount of time that it would take for the horse and in the amount of time that it would take for the gap between the horse and the light beam to be 300,000 kilometers, it should be, well, we'd have to adjust for the length contraction as well, but that would agree with what the horse observes as well. You would just have to sync up, like, you would have to put yourself in the horse's shoes where they see, that's a good joke, by the way, where they see their clock moving at a certain rate. And so what's happening is they see the universe as a whole is compressed. So they're able to cover, they see that, from 1 meter, in 1 second, what is 300,000 kilometers for them might not be very far for other people, or vice versa. So what's happening is that you have a conspiracy between the time dilation and the length contraction that makes it so that both perspectives are correct.
Right, okay. Interesting. Yeah, I guess like that is where I was a little bit confused, is like how that would work from two different viewpoints.
Mm-hmm.
Yeah, that makes sense. And then I had another question that it's not definitely not physics related, but
sure.
So, do you like operate under like an objective normative ethical framework or no?
No, I'm not an objectivist, or I'm not a moral realist.
Oh wow. So are you an error theorist, or are you just a subjectivist?
I'm pretty agnostic about it. I'm, on some days I'm like an anti-realist of some kind with like, perhaps like a praiser subjectivist. And other days I'm like a quietist, and I think that this is all just very confused language. So, it just depends on the day.
Okay, cool. Well, appreciate it. Thanks for having me up.
Of course, thanks for being here.
Yep.
Yeah, so the whole business of special relativity is mind-bending. But so the thing to think about is that the clocks and the distances, the clocks and the rulers are changing depending on whose perspective we're looking at. And it always changes in exactly the right way so that it works out. Look, so it is noon. Let me make sure I didn't miss any chats. Any questions in the chats? It looks like I didn't. So it is noon, which means that I should end the live stream and I should go, eat lunch and feed myself. I have a doctor's appointment in a little bit. But I will be on the line today at 6 p.m. Central. So make sure to tune that in. So I'm going to do this once a week. So if you want to ask questions for an extended period, if you want to come up and get your questions answered, consider becoming either a super fan on TikTok or a member on YouTube. And I'm going to try to figure out a way to filter members only for next week. So tune in and consider becoming a supporter in that way. Take care, everybody.